Hi students, welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher, and a very good evening to everyone here. So this is day 3 of organic chemistry, and in 5 days we are going to cover full organic chemistry, right? And I assure you that this is the best way of studying organic. First is GOC, then we have isomerism. We have completed GOC in depth, right? We have completed isomerism in depth. Everything I have covered in day 2 about isomerism. Now in day 3 we are going to cover naming reactions, right? So total we have 61 naming reactions that we are going to cover today, along with the questions that are directly asked on naming reactions of your previous year question basically, right? We are going to discuss about the previous year questions of JEE that are based on the naming reaction. So I have already done my homework, written all the handwritten notes for you, because I know that this time is very precious for you, right? So even every single minute is precious for you. So that is why more thing will be towards making you understand the reaction rather than writing it down, right? The notes will be provided on Vedantu JEE English, and moreover it is also uploaded on the Jungle Box. You don't have to worry about that. You don't have to write the notes, right, while I am teaching you. That's not any problem, right? Because you will be provided with that. Just focus on what I'm telling you. Focus on understanding the reaction and what kind of questions are asked from that question. Okay? Yes, everybody? Okay. Okay, Nanthu, don't worry. You still have time, right? You still have time. We'll still, if you start from now only the right way, right, the revision will be very good, right? So that is why I have picked out this revision series where you can just combine everything, right? Instead of learning chapters individually, learning this way, organic chemistry, I think that is going to be the best way, right? Okay. So shall we start? Shall we start, everybody? If you want me to start the lecture, then spam the chat box with green heart, so that with a very positive vibe and with a very beautiful smile on your face, we can start this lecture, right? We don't want to be tense throughout the lecture. We want to smile. We want to learn, right? We are gaining knowledge. We are gaining our marks, right, ma'am? How many questions I can expect from this? See, directly you can expect question like 3-4 questions directly, or maybe more. This I'm minimum I'm telling you, right? Maybe more, like, because I have taken out all the important part of from every single chapter. This is going to be the most important lecture. Okay? Yes, everybody, spam the comment section with the green hearts. Yes, everybody. Very good, very good, very good, very good, very good. Chalo. Now let us start the session, right? Total 61 reactions we'll be discussing about here, right? All the reaction have a specific name: reactant, reagent, product. Where you need the mechanism, I'll also teach you the mechanism, right? Wherever it is in need. Where you don't need the mechanism, there I will not teach you the mechanism. It will be only where you need it, right? Next thing is, we'll be also discussing about distinguished test as well here on this lecture only. So first reaction, guys, now let's pump up our energy, right? The first reaction is going to be Darzens reaction, right? In Darzen reaction and Reed reaction are quite similar to each other. So I'll tell you both of these reaction, right? So if you talk about the Darzen reaction, in Darzen reaction you use alcohol, then you add SOCl2. And what is this SOCl2? This is thionyl chloride, okay? This is thionyl chloride. Thionyl chloride. That is called the SOCl2. If you talk about, there is one more thing, that is SO2Cl2, that is called sulfuryl chloride. Sulfuryl chloride. Thionyl chloride is used in Darzen reaction. This is used in Darzen reaction, and this is used in Reed's reaction. I'll also tell you what exactly is Reed's reaction. Firstly, let us see Darzen reaction. Here we have alcohol. This OH will be replaced by Cl when you add thionyl chloride in presence of pyridine here, right? And you will get SO2 and HCl, which are vaporizable. That is why this is the best method of converting alcohol to alkyl halide, right? Now, ma'am, what is this Reeds reaction, ma'am? Can you please tell me what is this Reeds reaction? Now, firstly, let us see what is this Reeds reaction. In Reeds reaction, what you have is, here you have CH4SOCl2, right? So, what I told you, what is this SOCl2? This is sulfuryl chloride. So, these two reactions are very similar to each other. Students tend to make mistakes in these two reactions, right? That is why simultaneously I am teaching you these two reactions here. In Reeds reaction, you don't have alcohol, you have hydrocarbon, that is, you have alkene. Now here what will happen, you have RH, you add SO2Cl2. What will happen, this H will be replaced by, the products are going to be same, H will be replaced by Cl and you will have SO2, right, in vaporizable state, and HCl also, right? But in Darzens reaction, the only difference is here you had ROH and here you had SOCl2, and the answer was same only. That was Reeds. This is your Reeds reaction and this is Darzens reaction. This is Darzens reaction. Got it? Yes, everyone. So these are two very, very important reactions that are quite similar to each other. That's where students tend to make mistakes. Right? Now, next reaction on your screen is, right, next reaction on your screen is Sabatier Sanderson reaction. Sabatier Sanderson reaction, this is basically when you convert alkene or alkyne into hydrocarbon, that is alkane, right? So here what we will use, nickel in presence of H2 at a very high temperature, right? Usually it is seen that when you are converting alkene to alkane, then we use around 200 degrees Celsius temperature. But when we convert alkyne into alkane, then we need even high temperature, that is 300 degrees Celsius. So this is your alkane. This is Sabatier Sanderson reaction. Okay. Next is Wurtz reaction. Now Wurtz reaction again are very important. All the reactions are important only, right? Now what is Wurtz reaction? In Wurtz reaction, you will have alkyl halide plus sodium and you will have one more alkyl halide. Here what you're going to do, there are 2-3 things that you need to understand. First thing is you will use dry ether here. Ma'am, why we have used ether? First thing is that. Why we have used a dry ether? Second thing is that. Now, we have used ether because this is sodium and this is your ether. This is your ether. Sodium is positive, ether has lone pair. That is why what will happen? It is by the electron donation, it is going to give us solvation energy. It will get solvated. Ether will get solvated with sodium. So it is going to give us solvation energy which will help in the reaction. That is why we have used ether here. Second is, ma'am, why you have used a dry ether? Why not moist ether? Now, dry ether is used because sodium is very reactive towards moisture and air. That is why we keep sodium in kerosene oil, right? So that is the reason we have used a dry ether here. Now, what we will do in this reaction, what we will do, here X, NaX will be eliminated and you will have double the number of carbons in the alkyl chain of alkyl halide. That means if I have CH3X, then I'll have the formation of CH3 and CH3. That means, can I say that always even number of alkene will be formed, right? So, that is very important to note that always symmetrical or even number of carbon atoms are formed because we are making it double. Ma'am, can't we make methane out of it? Not possible, right? So, you need to write it here. One more thing, that methane is not formed. Methane is not formed. Odd number of carbon or unsymmetrical are not formed. Can you tell me the reason? Why odd number are not formed? Why methane are not formed? See, first thing is odd number are not formed because, for example, I am saying that you are making any odd number, right? You want to make propane here, CH3, CH2, CH3. This is what you want to prepare. Now, for this, I have two options. I can use CH3X and I can use CH3, CH2X, right? But here what will happen? First thing is, CH3 will react with itself and it will give us CH3, CH3. Second product will be this ethyl halide will react with itself and it will give us double the number of this. So answer will be butane, that is CH3, CH2, CH2, CH3. Third is when these two will react with each other, then we will have the formation of CH3, CH2, CH3. That means mixed alkanes are formed. So it is very difficult to separate them. That is the reason we don't use this method for odd number of alkanes or unsymmetrical alkanes. And methane is not possible because always double the number of alkane is formed, and this is methane is only one carbon. So double is not possible. You can't use half carbon and double it by one, right? So that is why methane is never formed here. Now, next thing to remember here is free radical mechanisms. Now, ma'am, what is this free radical mechanism? Free radical mechanism. Here, you don't need to remember the full-fledged mechanism. What you need to remember here is, see, if you want to see the full-fledged mechanism, you can see, but you don't need to remember this. What you need to remember is it is a free radical mechanism, that's it. What is full-fledged mechanism? Here, what will happen? Firstly, homolytic cleavage will occur between alkyl halide. You will have the formation of R free radical, and then R free radical and R free radical will combine to give you R, that is double the number of alkene, right? But ma'am, how I am going to use this free radical mechanism in my questions? How they are going to ask you the questions, okay? So I am just giving you the questions here. Here it is, you have a compound, right? This is, let's say you have this compound. Firstly, I am going to talk about this compound. You have this compound, right? So whenever you are answering, you will answer it in the format of free radical mechanism. So firstly, you will eliminate two bromine atoms here, doing the homolytic cleavage on both sides. Here also you will do the homolytic cleavage. Here also you will do the homolytic cleavage. So what will happen? You will have the formation of CH2, CH2 free radical, right? Okay. Here also we will do the same thing. Just do the homolytic cleavage and you will have the formation of two things, that is this thing, that is this thing. Wait a minute, that is this thing, okay? This is free radical over here and one free radical over here, right? So, now once you have made the free radical, if you have two free radical only in one compound, right? If you have two free radicals, just like here and here, we have two free radical only in one compound. So, two possibilities can happen. Either it can be intramolecular or it can be intermolecular free radical mechanism. That means they both will together combine, right? So, intra and inter are the two possibilities. I am going to draw it here. This is inter and this is intra, right? Again, I am going to draw it here. This is inter and this is intra and this is intra. Now, if you talk about inter and intra, which is going to give you the major product? Always intra is going to give you the major product, right? Always and always intra will give you the major product. But here one thing to remember is that intra is going to give you the major product, but here the problem is that if you have any anti-aromatic compound, then inter will be the major product. I'll give you one example. Here firstly just first thing is make the intra product. Here intra product means these two will combine together and what will be the answer? Answer will be CH2 double bond CH2. Now, is this anti-aromatic? No, ma'am. This is non-aromatic. It is not cyclic. So, ma'am, this is non-aromatic. If you have non-aromatic, then though you don't even have to think about the intermolecular intercompound. So, that is why this is going to be the major product. Intra, you will not even think about. Inter, you will not even think about. There will be no, it will prefer intra only, right? Now, if you talk about this thing here, make the intra product. That means these two dots, they will combine together to make a bond. So, it will be this kind of structure. It will be this kind of structure. Now, guys, once you have this kind of structure, first you tell me, is this aromatic? Is this anti-aromatic? Right? Okay, Madhu, I'll definitely see that. Right? After this lecture, I'm going to reply to the Insta story. Okay? Yes. Chalo. Now guys, tell me, if you have seen this in the NEET channel, then I would advise you one thing, that some reactions are not there in NEET, but they are there in JEE. So that's why I have added those reactions here, right? Okay, yes. So if you have already seen it, you can watch the recorded version after that, but go through those reaction as well, which I have not covered there, right? Because there is slight difference, right? Okay, now tell me, acha, ma'am, explain once more, sure. Just remember one thing, when you are doing intra and inter, right? For example, you have two halogens in one structure, right? Dihalide it is. So in that case, firstly you will make the free radical by homolytic cleavage. Once you have made the free radical, right, the free radicals will join together to make a bond, right? Always and always they will prefer intramolecular. If they have two free radicals in one compound, they will prefer intramolecular. That is why intramolecular product will be formed. But in some cases, you will find that you have anti-aromatic compound like this, which is having 4 pi electrons. So it is anti-aromatic. So it is anti-aromatic. Because this is anti-aromatic compound, that is the reason it will be very difficult, right? So that is the reason, and nobody in this earth wants to be unstable, right? So why would a compound want to be anti-aromatic? That is why now it will not prefer intramolecular, now it will prefer intermolecular. That means it is going to form this kind of compound that you have. This is one. This is inter, means when two different molecules are combining together. Here you had one free radical, one free radical, one free radical, one free radical. Now two free radicals will combine with each other to make a bond. Now tell me, is this anti-aromatic or no? This is not anti-aromatic, this is non-aromatic. Non-aromatic is definitely more stable as compared to anti-aromatic compound. So here it is going to prefer intermolecular, not intramolecular structure, right? Okay, yes. Chinu, you need to see my first lecture, day 1 of GOC. There I have explained it in detail, that what is aromaticity, anti-aromatic, aromatic, everything I have explained there. Okay, yes. Now, next is Wurtz-Fittig reaction. So, Wurtz reaction is basically when you have two alkyl halide, right? Wurtz-Fittig and Fittig reaction are same. It's just that in Wurtz-Fittig reaction, you have one alkyl and one aryl halide, right? That is why you will have this kind of structure, right? Now here also we have done the same thing. X from here, Na from here, and X from here. These things will be eliminated, and you will have this R and this phenyl ring will combine together and to give us the product, right? In Fittig reaction, when you have two aryl, just remember that Wurtz is alkyl and Fittig is aryl, right? When you have one Wurtz reaction, both are alkyl. When you have Wurtz-Fittig, one is alkyl, one is aryl. When you have Fittig, that means both are aryl. So here what will happen? You will take out Na and X from here, and you will have the formation of diphenyl, or you can say biphenyl will be formed here, right? Okay, yes, chalo. Okay, next is soda-lime decarboxylation reaction. Now there are two kind of decarboxylation reactions. One is soda-lime decarboxylation reaction, other is soda-lime, and there is Kolbe's electrolysis, right? Now, soda-lime decarboxylation and Kolbe's electrolysis, the mechanism is important for you to understand, because one is following free radical mechanism, other is following carbon-ion mechanism, right? Now, you don't need to get know the full mechanism here, just know that where you have the formation of carbon-ion. If you talk about the soda-lime decarboxylation, here you need to understand that here you have the formation of carbon-ion. How it is formed? Basically, in this carbon-ion, this electron is donated here, this is donated here, you have the formation of carbon-ion. And decarboxylation means carbon dioxide is eliminated from here, and this R negative plus H positive, they will make the alkane. Now, two things to remember here. First is that carbon-ion is the intermediate. Second thing is that you will have the alkane will be this alkyl group that you will have, right? That means in this carboxylate ion, there will be one carbon less in the alkane, right? If this is RC, for example, this is CH3COONA, then you will have the formation of CH4 because only this alkyl group will form the alkane. This CO2 will be eliminated from this side, right? So that is important because in Kolbe's electrolysis a different product is formed, right? Now, how they can ask you the question based on this and GOC, as I have already told you that GOC either direct questions can be asked or they can ask you questions which are not direct but they are a combination of GOC and your reactions, right? So that is why it is important to note that what kind of questions they can ask you in combination with the GOC. Those who have not watched GOC lecture, Day 1 GOC, the playlist is here on this channel only. I have just taken this 3-4 days before, right? So you can go and watch that, right? There I have covered everything, right? Inductive, resonance, aromaticity, everything I have, a hyperconjugation, everything I have covered there, right? Now, let us see the rate of reaction. Now, we know that this will be carbon ion, this will be carbon ion that will be generated here. And the rate depends on the carbon ion that you will generate here, right? What will be the carbon ion that will be formed? The carbon ion formed will be like this. The carbon ion formed will be like this. This thing will be eliminated and this will be the carbon ion that is formed. Here, this is the carbon ion that is formed. Here, this is the carbon ion that is formed. Now, you need to tell me which carbon ion is more stable, this one or this one. Where intermediate is stable, that means that reaction will proceed at a faster rate, right? So, this carbon ion is stable or this carbon ion. If you talk about this thing here, we know that CH3 is giving us plus psi effect, right? So, here it is giving us plus psi effect. That means it is donating, right? What about Cl? Cl is giving us two effects. One is it is giving us minus I, other is it is also because of the lone pairs, it is giving us plus I as well. It is giving us plus I effect as well. Now you will say, ma'am, which will dominate? Which will dominate? Bacha, very, very important to note down here. Everywhere, if you talk about other groups, mesomeric effect is going to dominate. But in case of halogens, mesomeric effect is not going to dominate, but inductive effect is going to dominate. So here minus I will be more than plus I. Only in case of halogen this happens. This is exception. That is why I have put down this question here. Now students, always remember that negative is like stress, right? So if someone is already under stress, you are giving them more stress, they will become unstable, right? Someone is already under stress, you are taking out stress from them by minus I effect. That is why this will become more stable. Hence, very good. I can see that in the comment section. That is the reason. This here the rate of reaction will be faster as compared to A. In B, the rate of reaction is going to be faster as compared to the A. Right? Okay. Next question, beta, on your screen, as you can see, that same kind of reaction we use for the formation of benzene. Right? In benzene also, by soda lime decarboxylation, same reagents are used, right? NaOH, CaO, right? Soda lime. I told you soda lime. This is soda, caustic soda. This is quicklime. So that is why the name is soda lime decarboxylation, right? You don't even have to cram this thing. This is soda, this is lime, and carbon dioxide we are eliminating from this thing, right? Now, next is that what will happen? This whole thing will be taken out. You will have the formation of benzene from here, as you can see on this page, right? Benzene is formed here, right? Next is Kolbe's electrolysis. So Kolbe electrolysis is also like soda lime decarboxylation, but here there are 2-3 questions that they can ask you, right? First is regarding the intermediate. Then the question can be asked regarding what is formed on anode, what is formed on cathode, right? These kind of questions can be asked. Let me tell you one thing, that here one more very important thing is that, as you can see, here you have the formation of free radical. And in Wurtz reaction also, you had the formation of free radical. Do you remember in Wurtz reaction also we had the formation of free radical? So even in this question, Kolbe's electrolysis, it is same as Wurtz reaction because the intermediate is same. Same thing is happening here, right? So here, first thing to see that how it is different from soda-lime decarboxylation. In soda-lime decarboxylation, you had the formation of RH, but here you will have the formation of RR. That is the first difference between soda-lime decarboxylation and Kolbe's electrolysis. Right? Here you will take out CO2, but double the number of alkyl chain will be formed as alkane. Right? Okay. Now, as simple reagent is simple electrolysis, water electrolysis, hydrolysis, right? That not hydrolysis, basically electrolysis is happening here, right? That means one will be anode, one will be cathode, right? Anode means there will be loss of electrons. So here what will happen? Homolytic cleavage will happen. One electron will lose, right? And it will have one O free radical over here. Then what will happen? This sigma bond also in the sigma bond also homolytic cleavage will occur, and one electron will be present here, one electron is also present here, so it will make a bond over here, and there will be elimination of carbon dioxide, that is CO2, right? So that is carbon dioxide will be eliminated, and here you have the formation of R free radical. Now similarly, from one more molecule you will have one more free radical, RR will be formed. So one thing you need to remember here, that at anode carbon dioxide is liberated and alkane is formed at anode. At anode carbon dioxide is eliminated and alkane is formed at anode only, right? Second thing to remember here, that at cathode what will happen? You have water. Here what will happen? You will have the basically it will be like this. This is OH and this is H, right? One electron will be added here. So there will be one more electron over here. So that is why what will happen if I talk about this thing, that there is homolytic cleavage. This will be OH free radical. One electron it is gaining. So it will be OH negative. And here you will have the H free radical over here. Got it? What is happening here? You had OH, homolytic cleavage will happen, and here you will have the formation of OH free radical. After gaining one more electron, it will be a minus charge over here, and one free radical is already eliminated. So these two H free radical are going to form H2 here, right? So what they can ask you, that at cathode what is formed? So at cathode you can say hydrogen gas is eliminated at cathode, and one more thing that they can ask you from here is, what is the medium? What is the medium? Can you tell me what is the medium? Here you have OH negative, here you had H positive. Basically this is nothing but this is RCOONA, so it will be Na positive, RO negative, so it will be OH negative plus Na positive, it will give you NaOH, which is going to be a basic medium, So one to word question they can ask you, at anode carbon dioxide and alkane is formed, at cathode you will have the liberation of H2 and the basic medium you will have, right? In the end you will have the basic medium. These are the 3-4 questions that they can ask you from Kolbe's electrolysis. Now ma'am, intermediates are free radical. So what kind of questions they can ask you, right? It is same as Wurtz reaction that we have done, right? Okay, just give me a second. Firstly, let me just show you the question that they can ask you. Beta, now you need to tell me one thing. This is the question. What will be the answer if there is electrolysis? If there is electrolysis, very, very important this is electrolysis, or if they are asking you question by adding soda lime, then what will be the answer? You need to tell me the answer of soda lime decarboxylation and Kolbe's electrolysis here, right? Yes, definitely it is very important, right? Now, all the naming reactions are important, guys. All that is why I am saying that this is a very, very important lecture, right? It is a conclusion of all the chapters that I am doing here, right? So here it is NaOH and CaO. Now, what you need to see here, that you have this thing, right? We know that in soda lime decarboxylation, you have the formation of RH. And in electrolysis, you have the formation of R. Just remember this thing. That means here you are just going to eliminate carbon dioxide and add H here. That means this thing will be formed here, right? Very good, very good, very good. In cyclohexane, you will have one methyl group. One methyl cyclohexane will be formed. What about this? Here, firstly, though, you will make a free radical. Firstly, a free radical will be formed. What is a free radical that will be formed? This free radical will be formed here. This free radical will be formed here. Now, if you have only one free radical on one compound, I have just one free radical, that means simply there will be one more molecule like that, right? They both will combine together, one more molecule like that. They both will combine together and give you what? Double the alkyl chain they will give you. So this will be one more free radical. They will combine together and they are going to give us this kind of structure. This kind of structure will be formed here. This is CH3 and this is CH3. Right? That is the answer for Kolbe's electrolysis. Got it? Okay. R is formed in case of Kolbe's electrolysis. Right? Okay. Very good, very good, very good. Got it, beta? Any problem here? Any problem here? Now, ma'am, what if we have this kind of structure? Ma'am, what if they have given us this kind of structure in the question, ma'am? If they have given us COONA and they have given us COONA and this is COONA and this is CH3 and this is Cl. Now, ma'am, tell me what is going to be the answer for Kolbe's electrolysis. Now, what is going to be the answer for Kolbe's electrolysis? Kolbe's electrolysis. What is going to be the answer? Everyone? Firstly, make a free radical. Take out this homolytic cleavage, right? So, what will happen? What will happen here? This is cyclohexane. Cl is present here. CH3 is present here. Carbon dioxide will be eliminated and here you have the formation of a free radical over here and a free radical over here as well, right? Two free radicals on the same compound. Now, I told you one thing in Wurtz reaction as well, that if you have two free radicals on same compound, then intra will be preferred, right? Then intra will be preferred, right? Until and unless you have any anti-aromatic compound, right? So now here what will happen? Intra will happen. That means these two will make a bond with each other only and hence you will have the formation of this kind of structure. Got it? Yes, bacho. Got it or not? Got it or not? Very important case I am telling you here, that if usually RR is formed, right? If you have this kind of structure, then the RR will be formed because only one free radical you have, right? But if, see, JEE means we are talking about, so good questions also we need to see, right? If you have two free radicals on one compound, then it will prefer intra, right? So these two free radicals will combine together to give us intra product. Next question, what they can ask you, if they want to confuse you even more, they are like, okay, we will test you even more now, right? So they have given you this compound. They have given you this compound. Beta, this we have done just now. In Wurtz reaction as well, I have done the same compound, same kind of structure I have told you in Wurtz reaction. Now in Wurtz reaction also what has happened, same thing will happen here. Firstly, make the free radical. Firstly, to make the free radical, what will happen? This is the free radical, this is free radical, this is free radical, right? Now we know that if you have free radical on one compound, it is going to prefer intramolecular. But if here it prefers intramolecular, I will have the formation of a compound that is anti-aromatic in nature, right? That is anti-aromatic in nature because it is having 4 pi electrons, which is 4n pi electrons. PCC it is following, planar cyclic complete conjugation it is following. Now that means this product is not going to take place. This reaction will not proceed this way. Instead, this reaction will proceed this way, that is intermolecular now will take place, because anti-aromatic compound is never preferred. So you have free radicals here. Now these two will combine together to make this bond, and this is going to be the answer. Okay? Yes guys, very good. Inter is preferred here. Is these 2-3 things clear to everyone here or not? Are these 2-3 things clear to everyone here or not? Now, Kolbe's electrolysis is also used in the preparation of alkene and alkyne, right? So that's why I'm telling you that I have made the lecture in such a way that all the reactions which are related to each other, I have put them in one category, right? Okay, that is why it will be very easy for you to remember these things, right? So this takes a lot of hard work. That's why for this hard work, don't forget to like this session, and that works like an appreciation to me. Like, okay, I have made a content for you. It took me around 4 to 5 hours to prepare this for you, right? So for that, so I need some kind of appreciation from you guys also, right? Now, this is alkene. Basically, what will happen? Again, beta, what will happen? RCH, this is CH, this is R dash. 2 free radicals will be formed here after eliminating COH. Then these 2 free radicals will join together to make the alkene here. That is how alkene is formed. In the similar way, if you talk about this particular structure, beta, here also I am just drawing the free radical that will be formed. RCH free radical. This is single bond CH. This is also free radical. This is R dash. Then you will have the formation of this thing. Here also same thing will happen. You will have the formation of RC double bond C R dash. After eliminating this thing, you will have this free radical, and after eliminating this thing, you will have this free radical, and hence when these 2 free radical will combine, they will form a triple bond, and hence alkyne will be formed from Kolbe's electrolysis, right? Okay, thank you so much beta, thank you so much. Okay, so here what will happen? Alkyne will be formed. So with Kolbe's electrolysis, alkane, alkene, alkyne, all of them can be formed, right? Okay, so now next thing is this we have done. Now Reeds reaction also we have done, right? In the first thing only, when we were doing Darzens reaction, I told you about the Reeds reaction there only, right? Now let us talk about Lindlar's catalyst, right? So basically, Lindlar's catalyst is also used in Rosenmund reduction. Okay, I'll just write it here because it is related to that. Also used in, you can write it, also used in Rosenmund reduction. Rosenmund reduction, right? It is also used in Rosenmund reduction that we are going to do today only, right? Okay. Ma'am, what is basically, if you want to prepare alkene from alkyne, there are 2 ways, right? One way you will form cis alkene, other way you will form trans alkene. Now, if you are using Lindlar's catalyst, you will have the formation of cis alkene. But if you are doing Birch reduction, in that case, you will have the formation of trans alkene. Got it? If you prepare, if the reagents are Lindlar's catalyst, then cis. If you have the Birch reduction, in that case, trans alkene will be formed from the same particular alkyne. Now what is this Lindlar's catalyst? Basically, guys, this is if you are using PD, that is a catalyst, and you are hydrogenating it. You are also using hydrogen in the presence of a catalyst. We have learned it in the Sabatier Sanderson reaction. If you remember this, we have learned this in Sabatier Sanderson reaction. Let me show you that alkyne are on catalytic hydrogenation are converted to alkene. If you are not using any poison, right? But if you want to decrease the rate, if you want to slow down that reaction to a particular step, then you will use a poison. And here the poison that we are using, is basically Lindlar's catalyst only, where this PbSO4, quinoline, sulfur, CaCO2, all these are poisons which are going to decrease the rate of reaction to alkene only. They are not going to convert it into alkane, right? Okay, and here you have the formation of cis alkene. What is Birch reduction? See, Birch reduction, we have two types of Birch reduction. One is this simple Birch reduction, other is a good level of Birch reduction, that is also very simple, right? But chances are they can ask you that in JEE, right? Now, with simple Birch reduction, right, very important, here what we do, we use sodium or lithium in presence of liquid ammonia, right? Here what will happen, this will get converted to trans-alkene, simple alkyne to trans-alkene. But if you are using Birch reduction in aromatic compound, then what is going to happen? That is a very, very good question, okay? Then what is going to happen if you are using Birch reduction in aromatic compounds? In aromatic compounds, same thing I am using, sodium, liquid ammonia, same thing I am doing. Now, remember one thing, that this three bonds, out of these three double bonds, one double bond will be converted to single bond. So what will be the answer? Remember this thing. If you have a simple benzene, two double bonds which are opposite to each other will be formed. So either you can have the formation of this compound, or you can also have the formation of this compound, or also you can have the formation of this compound. That means simply the double bond should be opposite to each other. If there is no substituent attached on it, we don't have even to think about it. It's just this can be formed, this can be formed, this can be formed. Any of this is the correct answer, because there is no differentiation among these carbons. All the carbons are same only, right? But if you have any electron donating or any electron withdrawing substituent attached on it. Now, those students who don't know what is electron donating and withdrawing, again, beta, GOC, I have covered it there. I have given you simple tricks based on that. And I have taken basically maybe 20 minutes, maybe 30 minutes. Mostly, I have covered previous year question in GOC, but I have taken 30 minutes for each thing, that is each electromeric effect, right? Okay. Electron displacement effect, I am saying electromeric effect for each electron displacement effect, right? Now, electron donating and electron withdrawing. Now, you tell me one thing, if someone is donating something to you, right? If someone is donating something to you, they're like, okay, do one thing, you can take my bike, okay? These are the keys, you can take my bike. You'll be like, hey, such a good friend, yaar. He's giving me his bike keys, yaar. Such an amazing friend, right? You will try to stay close to them, na, because they are benefiting you, right? So here, electron donating means someone is donating you the electron, so you will be happy with them. That is why the double bond will be next to it. Double bond will be next to it, and the other double bond will be opposite here, right? See, in Birch reduction, always the double bonds are opposite to each other. Here, any of this can be the answer, but in electron donating group, only the double bond should be next to the electron donating group. That means if this is electron donating, double bond should be close to the electron donating group. So answer can be either this, or the answer can also be, here if you have electron donating group, or the answer can also be this double bond here and double bond here. Both are the correct answers here. Okay, both are the correct answer here. Now, if you have electron withdrawing group, if someone is taking out money from you, they're like, okay, hey, can you please do this? Can you please do that for me? This and that, always asking for favors. And when it comes to give you any favor, they're like, okay, bye-bye, Tata. I don't have this, I don't have that. Right? So you will meet these kind of people. Like they just know how to take advantage. They don't know how to help. Right? So try to stay away from these kind of people, right? Chemistry, beta, it teaches you everything. Chemistry teaches you everything in its bonds, formation and everything, right? So, electron withdrawing is like, I don't want to stay close to this person. I want to stay away, right? So, that is why the double bond is definitely opposite, but it is not next. It is next to next. That means it is trying to stay away from the electron withdrawing group, right? So, answer will be this, right? Okay, got it, everybody? Right, okay, right, chalo. Now, next is, Hanji. Beta, they will give you only this kind of situation where you have one electron donating or electron withdrawing, right? Okay, other situations they will not give you. right? Okay. Now, next is Wittig reaction, right? Wittig reaction. Bacha, all the students, if you have any other query, any other specific session you want me to take on organic chemistry, do one thing. You can, because chats will to go, right? So that's why I won't be able to, after the class, I'll think about what else I can do after this series of organic chemistry, right? Then you can write down what are the problems that you are facing. Do you want me to pick out previous year questions only? Do you want me to pick out some specific chapters, some specific session? You can write it down in the comment section after the end of this lecture, right? Okay. Now, next question is Wittig reaction. Wittig reaction. So, Wittig reaction, again, mechanisms are not important for you here, right? I am telling you where the mechanism is important. Where the mechanism is not important, there you don't even need to think, right? Here, basically, bacha, what will happen? You have RCOR, you have a ketone, and this is phosphorus yellide. Okay, so in this, phosphorus is having only 4 bonds, that is why there is one positive charge on the phosphorus, right? And here CH2 is having only, carbon is having only 3 bonds, that is why there is one negative on the carbon, right? To fulfill its tetravalency. Now, here what will happen? Basically, this double bond will stay as it is. Here, this double bond will be picked and will give this double bond O to this side, right? We'll just pick this double bond O and give it to this phosphorus, right? And here, this double bond will stay intact, and here you will have the formation of CH2. Got it? What will happen? This CH2 will jump here, right? And this double bond O will jump here. And this is how you will have the formation of alkene and this, right? Okay, this is how phosphorus, why it does not have it, why now phosphorus does not have any positive charge? Because phosphorus, 5 bonds it wants to make. Now it has completed its five bonds. So that why it will have any positive charge over there, right? We have completed the valency, right? Okay, so this is the formation of alkenes from ketone, that is Wittig reaction. Okay, that is called Wittig reaction. Next is hydration of alkenes. So guys, basically these are 3 different mechanisms, 3 different naming reactions, but I have covered these 3 in just one only, right? So basically if you count all of them, so today we are doing 65 naming reactions, like what all the naming reactions that are in your syllabus, right? Hydration of alkene, right? Hydration of alkene is done. This is a very, very important concept, and based on this concept, you will see a lot of previous year questions are asked, right? So basically, this is hydration of alkene. Now, hydration of yes. Now, just remember one thing. Here we are making alcohols. Now, where you will have primary, secondary, what kind of alcohol will be formed, right? What are the paths? That is important for you to remember, right? In all the cases, we are making alcohol only. But when you have acidic hydration, that means you are making H2O and H positive, you are adding water in acidic conditions. Here you will follow that carbocation will be formed. After the formation of carbocation, the rearrangement will occur. After the rearrangement, attack of OH negative on the carbocation carbon will occur here. That is the first thing. Second is if you have hydroboration oxidation reaction. In hydroboration oxidation reaction, right, BH3, H2O2, NaOH you are using. After that, what will happen? Anti-Markovnikov rule you will use. That means negative part, that means OH negative, it will be to less number of hydrogens. Wait a minute, not more number of hydrogen, more hydrogens. Okay, negative part will be towards more number of hydrogens. And if you talk about the Markovnikov rule, here negative part will be towards less number of hydrogens. Less hydrogens. You usually in books what you will see that this acidic hydration is also following Markovnikov rule. But here one mistake that students do, that exactly here we are exactly following Markovnikov rule, because here in this particular reaction there is no formation of any carbocation, right? But in the first reaction there is a formation of carbocation. So whenever there is formation of carbocation, rearrangement might happen. If rearrangement is not happening, then so it is Markovnikov rule only. But what if rearrangement happens? Then so if you directly apply Markovnikov rule, then you will get the answer wrong. That is why I tell students not to apply Markovnikov rather than rearrangement of carboctane. This is the modern way of Markovnikov rule. Right? Okay. So here beta, next question is Tidin's reaction. Tidin, right? So Tidin's reaction is the formation, you have one alkene, right? In this you are adding NOCl. What will happen? Pi bond will break and Cl will be placed on less number of carbons, less number of hydrogens. NO will be placed on more number of hydrogens, right? And hence you will have this as your answer, and here it will be H2, right? Okay, and here it will be, wait a minute, here it will be H, right? Okay, so simple, right? Negative part 2, less number of, basically this NOCl, Cl will place here and NO will place here, right? Pi bond will break, that's it. Here also no mechanism, nothing is asked. Maybe they will give you this reaction directly, or maybe they can ask you in some sequence based reaction where A to B, B to C, C to D, D to E, what is E. In that maybe one step will be Tidin's reaction, or they can just directly ask you that what is the name of this reaction, something like that. Okay, yes, chalo. Yes, Markovnikov rule without rearrangement in the third reaction. Okay, yes. Now, next is Baeyer's reagent. Baeyer's reagent. Now, what about Baeyer's reagent? Baeyer's reagent, Bacha, are you able to see me? Are you able to see me, or is there any lagging? Are you able to see me, guys? If there is any lagging, then let me know in the comment section. Oops, Minhaj. Oops. You see the notification at 6. Oi, hoi, I told you guys it will be at 5 p.m. Chalo, no issues. You can watch the 1 hour after this class, because we are talking about naming reactions. They are not that much related to each other. All the reactions are different, right? All the reactions are different, right? So you can start from now, and after the class ends, you can watch the first 1 hour, but don't skip it, right? Okay. Yes, Pita, Sumit, I also teach inorganic. I have already taken up inorganic. Acha. Now, Baeyer's reagent. Baeyer's reagent is basically, this is a test of unsaturation. Here what will happen? You will use cooled diluted KMNO4, potassium permanganate we will use, cooled and diluted, right? Cold diluted 1% KMNO4 you will use. We know that the potassium permanganate is pink in color. What will happen? Its pink color will decolorize, right? So here what will happen? You will have the formation of vicinal diols will be formed here. That means this pi bond will break and OH will be attached here. That means the formation of vicinal diols. The formation of vicinal diols will be in Baeyer's after you react alkene with Baeyer's reagent. And here one more additional point is that brown color of PPT of MnO2 and glycol is formed here, right? Brown color PPT is formed here, right? But the pink color will disappear. That will tell you that there was alkene that was present here. Right? So it is also the test of unsaturation. Next is Wacker's process. Again, a simple like direct reaction, right? No mechanism, nothing, no difficult question will be asked here. Simple, you just need to go through this reaction, right? Basically, here you have alkene. When you add PdCl2 and CuCl4, this will be converted to aldehyde, right? So here what will happen? One hydrogen you will give it to this side. The same number of carbon, you will produce a aldehyde with the same number of carbon that were there in the alkene, right? So here you have the formation of ethanol. Simple, that is called Wacker's process. Okay, that is called Wacker's process. Next question is Groove's process. Beta, I am telling you where you need to have the detail. Here you don't need to have the detail because they don't ask this often, right? If they ask you, they will ask you directly that this is the question, this is the reagent, what is the answer? That's it, right? Mechanism and all, they will not ask here. I'll give you the mechanisms also where they are going to ask the mechanism, right? Okay. Next is Groove's process, or this is also called Lucas reagent, right? Usually students know that Lucas reagent, but Groove's process, they don't know, right? Okay. So Lucas reagent, where this is the reagent and this whole process is called Groove's process. So here what exactly we do? This is basically a distinguished test for 1 degree, 2 degree and 3 degree alcohol, right? First test is Groove process, or you can say Lucas reagent. Other is Victor-Meyer test. So I will tell you both the tests, Victor-Meyer and Lucas reagent, both the test here, right? Now, if you have 1 degree alcohol, right? First, let us start with 3 degree alcohol. Basically, here turbidity is formed, right? If you talk about the reaction, OH is replaced by Cl here in presence of anhydrous ZnCl2 and HCl. In 3 degree alcohol, see, distinguished test means you need to see something here, right? In Baeyer's reagent, I was able to see that pink color is disappearing. Here also I need to see something because I can't see the compound, the structure of the compound by my naked eye. That's not possible, right? So that means some color, some liberation of gas, something should happen, right? So here you have the cloudiness or the turbidity. So 3 degree alcohol, the turbidity appears immediately. Immediately, that means as soon as the reaction happens, this will appear immediately. What about 2 degree? This will appear after some time. What about 1 degree alcohol? If you have 1 degree alcohol, primary alcohol, in that case, turbidity will appear after 30 minutes, and that too after prolonged heating. If you heat it, prolonged heating, that will happen around 20 to 30 minutes. After that, you will see some cloudiness, but you need to heat the mixture. Only then turbidity will appear here, right? Okay, yes, right, within minutes for secondary. Yes, very good. Next is halogen. Acha, firstly, so let us do Victor-Meyer test. That is related to this thing only, right? Let us do Victor-Meyer test. So this is the Victor-Meyer test. Victor-Meyer test. In Victor-Meyer test, you have 1 degree, 2 degree. Most welcome, Satvik. Most welcome. Right. So this is Victor-Meyer test. Again, this is distinguished test for 1 degree, 2 degree, 3 degree alcohol. Same thing. Here, you don't need to remember the reaction. I have written the reaction here. You don't need to remember it. Okay. Let's be very clear. Right, you don't need to. If they say in 1 degree, 2 degree, Lucas reagent is a very like normal, aisa they ask even in boards, in NEET, they ask this. Victor-Meyer, they can ask you in JEE, right? But they can ask you what will happen in 1 degree, what color will be formed in 2 degree, what color will be formed in 3 degree. Color is what you need to remember here, right? So in primary alcohol, you will have the formation of red color. In secondary, you will have the formation of blue color. And in tertiary, you will have the formation of, this is basically colorless. So you can remember this by R, B, C. Okay, R, then you have blue color, B, then it is colorless, right? 1 degree, 2 degree, 3 degree, right? Okay, 1 degree, 2 degree, 3 degree. This is your Victor-Meyer test. Now, ma'am, if I want to remember the reagents, yes, you can remember the reagents, what exactly we are doing. Because what if they don't tell you that you are doing Victor-Meyer test, but instead they are telling you that you are adding HI, then you are adding AgNO2, then you are adding HNO2, right? And then you are adding a base, OH negative, right? Then you are adding a base. Then what will happen, right? In that case, 1 degree, red color, 2 degree, blue color, 3 degree, no reaction, colorless. Okay, yes, okay, beta. Very good, Ratan. Now, what Ratan has told here, those things we will do in the important reagents, right? Because apart from naming reaction, this, so I am telling you proper names, right? There are also other reagents which don't have a specific name, but they are very important, right? Okay, we will do those things in important reagents lecture, right? Okay, Chalo. Now, Victor Mayer test also we have covered. Acha, next is, oh my God, this also done. Next is halogen exchange reaction. So halogen exchange reaction, yes, halogen exchange red blood cells. Halogen exchange reactions are two main reactions we have: Finkelstein reaction and Schwartz reaction. Okay? So I have a very funny trick for this, right? If you have a better, then you can tell me. So I call it by Rogza. Okay, this is our Rogza. This is a girl who is Rogza, who is very like high tantrums, right? She is throwing tantrums everywhere. Now this is a guy called Finn. Finn is asking Rogza that Rogza, why don't you apply acetone? Acetone is what? Nail paint. Why don't you apply acetone on your fingers? Be little bit, do some fashion, right? But Rogza is like, I don't want to do that, right? I am very like, I don't want to agree with you. Like I have so many tantrums, I will not agree with anything that you say, right? So Rogza will be no, that I don't want to agree with you. Right? Just remember this by Finkelstein, Rogza, nahi, acetone. Right? Now here what will happen? Exchange will happen, halogen exchange will happen. You will have the formation of Ri and NaX. Now the question is why we have used dry acetone here. Why we have used this? Now students, basically the thing is that this is also a polar compound. This is also a polar compound. Right? So basically NaI is not soluble, right? NaI is soluble in dry acetone. That is why to make the reaction, see, if you don't use dry acetone, then NaI will not react with Rx. It will not react with Rx. The one NaX means X, halogen, X is the halogen. That sodium halide which is soluble in dry acetone, that only we can use. Right, so here I have used NaI, that is why this is soluble in dry acetone. That is why, suppose this is NaI, this is these are your two friends, Rogza and NaI, right? So now they both are not talking to each other. So what you will do? You are dry acetone. You will call NaI to your house. You will say, hey, can you please come over to my house? Right? You will also call Rogza there, right? Then you will say, okay, please talk to each other, this and that, right? You will make them talk to each other so that your group, right? We know now in groups always fights happen. So same, they are fighting with each other, right? So in same thing, basically, Rx will not talk to NaI unless and until NaI is dissolved in dry acetone. Right? Okay. So here only then to make this reaction happen, we use dry acetone here. So here they both halogen exchange will happen and you have the formation of Ri. Now, basically usually this reaction is a reversible reaction. But the thing is that what we have as a byproduct is NaX. Now this NaX is actually precipitated in dry acetone. That means here if I say NaCl or NaBr are not soluble in dry acetone. Only NaI, very very important thing it is, okay. Only NaI is soluble in dry acetone. NaCl and NaBr are not soluble in dry acetone. That is the reason they will form a precipitate here. That is the reason we can have pure Ri here. And when the product is getting consumed, it is getting out, right? By Lee-Chartley principle, we know that this is mentioned in your NCERT also. That by Lee-Chartley principle, we know that if we are consuming the product, then what will happen? The reaction will jump forward, not backward. That is why it is towards forward direction. Okay? Yes? Okay. JEE aspirant, beta, I have already done that. You can see that last week only I have taken 2 classes of inorganic chemistry. First class I have completed chemical bonding coordination. Second class I have completed block chemistry. Right? Okay? Chalo. Now, here what they are telling you, we know that NaCl is not dissolved, is not soluble in dry acetone. Now, NaCl is like, I don't want to talk to Ri also, I don't want to talk to dry acetone also. Array, this NaCl don't want to talk to dry acetone also. So will it like be, okay, I can come to your house and then you will say, hey, you both can be friends? No, it's like, I don't want to talk this diacetone also. So if it is not soluble here, then how can reaction occur? So that is why here we use NaI, NaCl, NaBr is not used here, right? Okay. Next is Schwartz reaction. Now I was telling that Roxa is very like a girl who is throwing tantrums everywhere. Hai. So this Roxa, but you know one thing about girls, na? One thing about girls, right? One thing about girls. Girls are like, I will not talk to, like I will not listen to my husband or boyfriend, or they will not listen to them. They will listen to their best friends. They will like, okay, my best friend is saying that there may be something important. Even if the best friend is dumb, they will listen to the best friend only. Right? This is the girls. Girls are girls, right? Even I do the same, right? So here, this Roxa is like Swati. Finn was like, when Finn asked her to do some fashion, Roxa was like, hey, just go away, okay? Nahi, nahi. But with Swati is like, hey, why don't you do some fashion? Why don't you do some fashion? Then Roxa was like, okay, if Swati is saying, then I can agree, then I'll do everything, right? So here, basically, Roxa, Schwartz reaction, and these are your inorganic fluorides, right? So here, you can remember this by all our inorganic fluorides. If you want to remember this AgF, then I have one thing, that is, so Ag is what? Silver, right? So when you do fashion, you wear silver and gold, right? So silver we are wearing. So F for fluorine, right? Okay, chalo. Now that's it. Then you have CH3Cl3, CHCl3 and AgF, right? Now, just giving you one example here that is mentioned in your haloalkanes and halorenes. If you have AgFCHCl3, in that case also what will happen? This one Cl will be replaced by fluorine, right? And this is called chlorofluorocarbon. Chlorine also you have, fluorine also you have, carbon also you have. This is called chlorofluorocarbon. And these are called freons, okay? These are called freons. They can give you this question and they can ask you that what is this product is formed. Maybe they will not give you this structure. They will give you freon is formed, CFC is formed. Then if they ask you freon, then students will get confused. Then they will say, ma'am, it is out of syllabus. Beta, this is mentioned in your haloalkanes, halorenes. In your NCERT only this is mentioned. Right? Okay, chal. Next question is, Williamson synthesis, again a very favorite reaction, Williamson synthesis reaction. See, so Williamson's wants to make ether, right? So this is Roxa and this is Rona, Roxa, Rona. So Williamson is saying to Roxa, now Roxa has met William, right? So William was saying, Roxa, please don't cry, Rona, right? So William was saying, Roxa, Rona, RONA. So now what will happen? This NaX will be eliminated here and you will have the formation of this ether, right? Ether will be formed here. That is why this is called Williamson synthesis, right? Ether formation this is, right? Okay, beta. Okay, Kshetra, I'll do that. Okay, don't worry. Yes, you give love to these sessions and definitely you will get more of these sessions. Okay, yes. So my input is like 100%, right? Now, what you are going to get, like what output you give me out after that, that will depend on you, right? Now, according to that output, more input will be provided, right? Okay, chalo. Now, beta, two very important things here. That alkyl halide that is used should be 1 degree. Very important here. Alkyl halide that you are going to use should be 1 degree alkyl halide. It cannot be 2 degree or 3 degree alkyl halide. For example, one question has been asked from here. One question, I'll just give you one question here so that this is like simple for you to understand. For example, the ether is CH3, 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 OCH3, right? They are saying that after Williamson synthesis reaction, this is the ether that you form, right? Now, the question is, what is the alkyl halide that you should use? What is this? Is RONA is alkoxide, okay? When you have to the alkyl, you have to when you have alkyl, you have ONA, then this is called alkoxide. When to the phenyl you have ONA, this is called phenoxide. Okay, chalo. Now, alkoxide you have. What is the alkoxide? What is the alkyl halide that you should use? So, if you see here, the alkoxide will be, it can be 1 degree, it can be 2 degree, it can be 3 degree. But CH3, alkyl halide, should be primary here. So, the alkyl halide that we use will be CH3X, and this 3 degree is going to be alkoxide. This is going to be alkoxide. Okay, this is going to be alkoxide. These kind of questions they can ask you here, right? Okay, these kind of question they can ask you here. Next is Frankland reaction, है ना? Frankland reaction. So zinc is a very frank person. You can remember this like that. That zinc is a very frank person, right? Okay, he'll get attached to anyone, right? So here, what will happen? Zinc is a very frank person. See, sodium and zinc are both are very frank. Right? If you have Rx here, right, this is Na, this is Xr, same thing will happen and you will have the formation of Rr. Similarly, in place of sodium, if you have zinc, that is called Frankland reaction. If you have sodium here, that was called Wurtz reaction. You can also remember this by, in Germany you have Frankland. In Germany you have Frankfurt, right? Very famous, right? So Frankfurt, if you remember, like if you have that much geography in your head, then you can remember this by Germany, Frankfurt. Germany, Frankfurt. If you don't remember that only, then you can just remember this by zinc is a very frank person. Zinc is a very frank person. So what will happen? Here you will have the formation of RR. One important point to write here. In Wurtz reaction and in Frankland reaction, you can't make unsymmetrical alkanes are not formed. Are not. Hello. Hello. No, ma'am, no voice, ma'am, no voice, ma'am. Now is ma'am audible? Ma'am is audible now. Arre, now is it audible? Now is it audible? I am so sorry. Yes, the phones, I think the mic's battery got discharged. Mic is also getting discharged these days. And I think mic is also not is feeling winters. In winters, the mic is also getting discharged. Like, okay, even I need some charging, even I need some blanket or something. Right now, okay, do from Frankland, where you were not able to hear. From this, you were not able to hear anything. From this, okay, chalo, do from Frankland. Okay, fine. So basically, what I was telling you, that Frankland is same as Wurtz only, right? In Wurtz you were using sodium, right? In Frankland you are using zinc. You can remember this by that Frankfurt is in Germany, right? So zinc, Frankland, or you can remember this by zinc is a very frank person, right? Okay, now important thing to note down here, that Wurtz reaction and Frankland reaction, both we can't form unsymmetrical alkane, right? But if you talk about new reaction, that is Corey-House synthesis, right? Okay. Acha. Now, if you talk about Corey-House synthesis, in this you can form unsymmetrical alkanes as well, right? In this you can form unsymmetrical alkane. That is why I was saying that this is important reagent. Now, this R2CuLe, Cooley, this is called Gilman's reagent. Okay, this is an organometallic compound just like Grignard's reagent. So, this is called R2CuLi, this is called Gilman's reagent, right? Now, guys, you don't need to remember these two reactions. I will not advise you to do that, right? Because they don't ask that, right? You just remember this thing that in Corey-House synthesis, right? In Corey-House synthesis, in a house, right? In a house, who wants to go? Gilman wants to go in that house, right? So Gilman wants to go in that house. So that's why with the help of a coolie, right? A coolie, right? That take out your luggage in the train, railway station, right? So coolie will take Gilman to that house, right? This is the story of this reaction. So this is R2CuLi R-X. This is alkyl halide, this is R2Ca. Both are different. This is R, this is R dash. They will make R dash. That means unsymmetrical alkanes can be formed. Unsymmetrical alkanes can be formed from Corey-House synthesis. Okay, Shubham Gill. Oh, kya baat hai? Very nice. To all the cricket fans, so Shubham Gill wants to go. Very nice, yeah, very nice. Shabash. So Shubham Gill wants to go to Corey's house, right? Some Gore, right? Foreigners are called Gore, na? So Shubham Gill wants to go Corey's house, and that's why he took the help of Cooley, right? Okay, chalo. Next is diazotization reaction. Diazotized reaction is a very, very important reaction. Here, beta, you need to know 2-3 things. First is, this thing is called aniline, okay? This thing is called aniline. When on the benzene, you have NH2, that is called aniline. And in aniline, if you add NaNO2 plus HCl, right? Or they can also ask you to add, HNO2, or they can also say that add NOCl. Right? Anything they can say. All these things are same only. They ask you NOCl. They ask you HNO2. They ask you NaNO2 plus HCl. Right? All these things are same only. Beta, what do you want me to explain? What do you want me to explain, beta? What do you want me to explain? This thing you want me to explain here? Nothing to explain. These two reactions you don't need to remember. These two reactions you don't need to remember. Corey-House synthesis is a formation of alkane only from alkyl halide using a reagent, organometallic reagent, that is Gilman's reagent. Now here unsymmetrical alkanes can be formed because in this Gilman's reagent you have R, this is R dash, they both will combine together, you will have the formation of unsymmetrical alkanes. In Wurtz reaction and in Frankland you were not able to make unsymmetrical alkanes, but here you can, right? Okay, chalo. Now, bacha, here this is aniline. Aniline, this is called basically diazotization reaction, where what we are going to do? We are going to replace this H2 with N2Cl. This is disonium salt. Okay, so what we are going to use? HNO2 or NOCl or NaNO2 plus HCl. This is just to confuse you. This is the actual reagent that you use after reaction HNO2 or NOCl. If they even tell you that NOCl in presence of 0 to 5 degrees Celsius, that means they are saying that they have added NaNO2 and HCl. It's just a way of confusing you. They should have used this thing, but they can also use HNO2, NOCl, HONO. These are the same things, right? Now, temperature should be 0 to 5 degrees Celsius. That means in cold it is stable. This disonium salt that we are going to form here is stable only in case of, beta, just give me a second, right? It is only stable in cold temperature. It is not stable in hot temperature, right? Now, guys, related to this, I have one more thing for you. That is, if you have RNH2, if you have amine, not aniline, you are using the same thing here. And then you say you have the formation of RN2Cl. R N2Cl, this is positive negative. Now important thing about this thing is, this is still stable at 0 to 5 degrees Celsius. It is still stable. I am not saying diazonium salt is a very stable compound. I am saying if you have 0 to 5 degrees Celsius, it is still stable. But this alkyl diazonium chloride, this is not even stable at 0 to 5 degrees Celsius. So it will directly, you just give it water, you just add water to it, right? You just add water to this. This will be converted to ROH directly. But here if you want to convert it into phenol, then you have to warm it. Then you have to add water. Then only this will be converted to phenol. Okay? Yes? Chalo. Now Veni is asking one example. Acha. Example beta, anything you can say. Let's give you example here only. Let's say you have CH3, right? Twice CuLi, right? And this is C2H5X. The formation will be, you will have the formation of CH3, C2H5. That means CH3, CH2, CH3 will be formed, which is an unsymmetrical alkane that we have formed here, right? Okay. You will have the elimination of CH3Cl, right? And that means this X that you are using. Plus you will have the elimination of LiX, right? Okay, that is the example. Chalo. Now, next is from diazonium chloride we have two reactions, that is Sandmeyer's. There are so many reactions, right? Some reactions have a specific name. So I am telling you those reactions which are having a specific name. Those reactions which don't have a specific name, but they are very important, that I will tell you in important reagents, right? Okay, then we will see the work of a reagent, right? Now, first is if you have N2Cl, you are adding CuCl to Sandmeyer. How to remember this? Sand is like, okay, you have sand, okay? Whenever you see sand is like a salt, right? So sand is on the beach, and on the beach you have a salt, right? So that is why we are using a salt here, that is Cu2Cl2 and HCl. That is why here you will have the formation of, on the benzene you will have Cl over here. On the benzene you will have which thing you are adding here? Cu2Br2HBr. That is why you will have the formation of bromobenzene over here. What about this one? Here if you have CuCN and KCN, here you will have the formation of CN on the benzene ring. Okay, this is called Sandmeyer's reaction. What about Gattermann's reaction? Gatter is like a gutter. In gutter, you would like, it's very smelly. Gutter is very smelly. That is why you need to use powder there. That is why we are using copper powder here in presence of HCl. The reactant and the products are same. The reagent is different, right? Here you will using a salt, that is CuCl2, CuBr2. Here you are using Cu powder, copper powder, right? So answer is same only. You will have the formation of chlorobenzene, and here you will have the formation of bromobenzene, right? Ma'am, can I also do the same reaction just like I did for CN? Can I also use copper powder in presence of KCN? No, right? So cyanobenzene is not formed in this case. In Gattermann reaction, you can't add CN over there. That is not a Gattermann reaction. In Sandmeyer reaction, you can use Cu, CN and KCN, right? Okay, chalo. Next is Balz-Schiemann reaction. Now, what is Balz-Schiemann reaction? Now, in Balz-Schiemann, just remember who has Bal. Bal means here, right? Here. Balz-Schie. So, she means a girl, right? Just a way to remember things, right? She is a girl. She is saying that I want to do fashion, right? So, she wants to do fashion, right? That is why she has added HbF4, right? She has added HbF4 and then heating it, we have converted this N2Cl diazonium chloride into fluorobenzene, right? Okay, now guys, important thing, if you add in diazonium chloride, if you have HbF4, then you also add NaNO2, then you add copper couple, then the answer will not be fluorobenzene, the answer will be nitrobenzene, but this is not a Balz-Schiemann reaction. This is not Balz-Schiemann reaction. Okay, this is not Balz-Schiemann reaction. This thing is called Balz-Schiemann. This is just a like same reaction, just like Balz-Schiemann reaction, because students get confused here. This is we are adding HBF4 only, but when you are adding HBF4 along with NaNO2 along with copper couple, then you have the formation of nitrobenzene. Okay, this thing is formed, right? Okay, okay, bacha. Chalo. Now, next we have is Hunsdiecker reaction. Now, in Hunsdiecker reaction, how to remember this? Again, a story to remember this reaction. The story says that you have bad criminals. Bad criminals. So, bad criminals, what they will do? They will take out something from you, right? So, decarboxylation will happen firstly here, right? And bad criminals will give you bad memories. That is why this was RCOOAG, right? AG, someone was wearing silver chain. Bad criminals will take out those silver chain, right, from them, right? So they have taken out silver chain. They have given them bad memories. So this is RBR. This is CO2 is eliminated, decarboxylation. And in presence of CCl4, you have the formation of AgBr and RBR here. So this is called Hunsdiecker reaction. Okay, this is called Hunsdiecker. Yes, silver salt of carboxylic acid is used here, right? Okay, chalo. Now next is Dow's process. Dow's process. In Dow's process, what you are going to do? Guys, please focus here. Please focus here. Right? Okay, please focus here. Chalo. Thank you so much, Mohammed. Thank you so much. Acha, Dow's process. It's again a very important process. Right? Basically, here they can ask you 3-4 kind of questions that I'll tell you. Right? First question that can be asked that if you talk about this and if you talk about any alkyl halide, right? This bond is easy to break as compared to this bond. What is the reason? Reason is because see, as you can see in the Dow's process, you are using 625 Kelvin. You are using 300 atmospheric. Oh my God, such a high temperature, such a high pressure to be used, right? So that means there must be something. That means to break this CCl bond, why I need such high temperature, high pressure? Because reason is, I'll tell you the reason. First reason is, it will have a double bond character due to the resonance. Due to the resonance from here, it will have a double bond character, partial double bond character. Second is, this basically, this is sp2 hybridized. This carbon is sp3 hybridized, right? That is why this sp2 hybridized, it is difficult to break this bond because this is more electronegative in nature. That is why this we can say sp2 hybridized carbon atom. Third, we can say that after, if you want to eliminate Cl from here, you will have the formation of this phenyl cation. This phenyl cation is not at all stable, right? Phenyl cation is unstable. First is this question that why we have used such harsh conditions in Dow's process. Reason is it is very difficult to break the CCl bond. Okay? Okay guys, chalo. Next is now here what you will have ONA after breaking the C. I'll also give you the mechanism, full mechanism over here. This is firstly what is going to happen with adding NaOH. You will have the formation of ONA. After acidification, you will have the formation of phenol. Another important question that can be asked here is, what is the intermediate? Just remember the intermediate here. Intermediate is benzene. What is benzene? On the benzene, you have one more bond here. The intermediate in Dow's process is benzene. Right, so let us see the overall reaction, overall mechanism. Beta, first thing is mechanism is not that important for you, but you can just go through that, what is happening, right? Base is taking out proton here. You have the formation, this is taking out proton here. You have the formation of a negative charge here. That is why this will jump here, this will jump here. Benzene will be formed. This is the benzene intermediate that is formed. After benzene, again, Here OH negative is acting as a base. Here OH negative is acting as a nucleophile. Right? That is why it is not taking out any proton here. It is just acting as a nucleophile that will attack here. Electrons will jump here and this thing will be formed. After this, you add H positive here. It is internally transferred here. Then you add Na positive, right? Because this NaOH, it will have OH negative and Na positive both in the solution only. That is why you will have sodium phenoxide. Then acidified, you will have the formation of phenol. What they can ask you, ma'am, do I need to remember the full mechanism? No, right? You don't need to remember the full mechanism, guys. Just understand what is happening. One time base is acting as a, OH is acting as a base. Other time OH is acting as a nucleophile. First thing. Second is, what is the intermediate form? That is important to know. Full mechanism, see for yourself. How can they ask you full mechanism in some objective question? But you should know the proper method so that if a twisted question is asked, then you can also answer that, right? Now, next is one more thing to remember here, which can be asked is, if you have, this is Cl, if at ortho and meta position, you have electron withdrawing group, then you just need to warm it and you will have the formation of picric acid, right? Then you can just form it and you will have the formation of picric acid, and picric acid is basically yellow in color. Okay, picric acid is yellow in color. Now, remember one point here, at meta position, no effect of electron withdrawing group, because in chlorobenzene, if you see the resonating structure of chlorobenzene, you will have at ortho and para position, you will have the negative charge. At meta position, you don't have any negative charge. That is the reason at meta position there is no use of adding some electron withdrawing group. But at ortho and para position, the harsh conditions will decrease in the Dow's process, right? So this question is very, very important for you. Okay, chalo. Next is after 30 reactions, I need to see your Josh, right? Okay, yes, picric Didi, very good, very good. Acha, what is this question, guys? This is Ullmann's reaction, right? Ullmann's reaction. This is basically the formation of diphenyl only, but in this is just like Fittig reaction, similar to Fittig reaction, but what we have done here, we have used idobenzene in copper. This will be eliminated, and hence you will have the formation of diphenyl here. That is same as Fittig reaction. Okay. Chalo. Next is very, 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 very important, Cumene's process, right? That is very important process, that is called Cumene's process. In Cumene's process, what will happen? First thing is, what is cumene? This isopropyl benzene is called cumene. Now, this is frequently asked question and it is one of the most favorite questions, okay? Now, how cumene is formed, that also you should know. How cumene is formed, for example, you have benzene. On benzene, you are adding some CH3. This is just one of the way of making cumene, okay? So, this is CH3, CH2, CH2, Cl. You are adding anhydrous AlCl3, right? Now, why I am showing you this reaction? Because I also want to teach you carbocation rearrangement here. We know that here Friedel-Crafts alkylation is happening, right? So that means this kind of carbocation is formed, CH3, CH2, CH2 positive. This is a which kind of carbocation? This is a primary carbocation. This will be rearranged to hydride shift will occur. This will be rearranged to CH3, that is 2-degree carbocation, right? So now this 2-degree carbocation will attack on the benzene and hence you will have the formation of isopropyl. This is CH, this is CH3, this is CH3. Hence you have the formation of cumene, right? Hence you have the formation of cumene. Now, don't restrict yourself, right? Why I tell don't restrict yourself? Because you think that, ma'am, only this reagent is used to produce CH3, CH2, CH2 carbocation. But if you use CH3, CH2, CH2, OH, right? Now, here also, if you add water over here, H positive over here, right? Here also OH negative will be eliminated and this carbocation will be formed. It will also do the same thing, right? Okay, got it? Yes, that's it. Chalo. This I'll tell you in questions as well. Next is, acha, cumene process, so I forgot to told you. Cumene process is basically when you have air, right? Okay, O3 is added here, right? What will happen? Not O3, yes, air is added here. Because of this oxidation, what will happen? Peroxide bond will be formed here, right? A peroxide bond will be formed here, that is OOH. After further hydrolysis in acidic medium, you will have the formation of phenol and acetone. Byproduct is also important, that always phenol and acetone is formed here, right? Always phenol and acetone is formed here, right? Okay, chalo. Next question is Kolbe's reaction. Now, what is Kolbe's reaction, guys? What is Kolbe's reaction? Kolbe's reaction is basically when you want to make from phenol, you want to prepare salicylic acid. Salicylic acid, right? Salicylic acid. Now, in phenol, what you are adding is NaOH and CO2 and H positive, right? So, NaOH is acting as a base. It will abstract the proton here. Then, I'll tell you the full mechanism here. Let us see the full mechanism. What is going to happen here? Basically, what will happen? Firstly, the base will take out the proton and hence you will have the formation of the phenoxide ion. Now, till here it is same as Reimer-Tiemann will have the same thing. What will happen? This negative will jump here. This double bond will jump here and hence there will be a more electron density site on this position, right? Now, we know that if you talk about the carbon dioxide, right, we know that this is more electronegative, this is electropositive, this is electronegative. This is having more electron density. On this carbon dioxide, this carbon is having less electron density, right? That is why what will happen? This negative will attack the electron rich, will attack the electron deficient compound, right? So it will attack on this and here you will have the formation of CO negative. Why? Because here when it is attacking here, carbon can't have 5 bonds. So these electrons will jump here, right? Now carbon only can have 4 bonds. Now what will happen? Again this bond will jump here, this bond will jump here, this electron will jump here and hence you will have the internal transfer of hydrogen and this thing will be formed. Even now what will happen? After this, Na is already in the solution. This is COO, Na is produced, right? After acidification, you will have the formation of salicylic acid. Once you have this thing, then so you know already that you just need to add H positive here and then you can already have your COOH, that is acid will be formed. Okay, simple thing. Base always and most of the mechanism, same thing is happening. Base is taking out proton, electron rich to electron deficient attack is happening, then you will have your product. Most of the reaction you will have the same things, right? Now, next is Reimer-Tiemann reaction. Reimer-Tiemann reaction and carbylamine reaction, they have the same electrophile, right? Okay. Now, basically what happens here, reagents are also same. You are using CHCl3 and NaOH. That is why the electrophile that is formed is dichloro, very, very important, dichlorocarbene. Dichlorocarbene, that is CCl2, this. Now students get confused that ma'am, this is electron rich, ma'am. How can you say this is electrophile? Ma'am, this is electron rich, ma'am. This should be nucleophile, beta. This is C, Cl, Cl, and this is the 2 electrons that I am showing. Tell me on carbon how many electrons you have. 1, 2, 3, 4, 5, 6. It is a 6 electron species. It is electron deficient. That is why it is acting as a electrophile, right? And this thing is, this is same in, you can write this here. You can write this thing here. This whole thing is same as carbyl amine or isocyanide. We will also do that reaction because that is also a very, very important reaction. Isocyanide test, right? Okay. Acha. Now, ma'am, here what we form. See, if you are using CH, very, very important thing. If you are using CHCl3, there will be formation of salicylic aldehyde. Now, they can also ask you that in Reimer-Tiemann reaction, if you want to prepare salicylic aldehyde, then, salicylic acid, then what you will use? If you want to prepare salicylic acid, then you will use CCl4. Then there will be formation of salicylic acid. Okay, these are very, very important points to remember, right? Okay, chalo. Okay, guys. Now, let us see this thing, right? That is done. Now, let us see the mechanism. Firstly, as I told you, dichlorocarbene is the electrophile here, right? So, same thing. This is the same step that you will see in carbylamine reaction as well, right? So, basically, base will try to abstract the proton here, right? The electrons are going to jump here. You will have C negative CCl3, right? So, carbene is a specific intermediate, just like benzene is a specific intermediate, right? So, now, after that, what will happen? Again, this Cl negative will be eliminated and this whole thing will be called as carbene, right? Okay, this whole thing will be called as carbene. Just like carbocation, carbanion, there is this intermediate called carbene. Nitrene is also one of the intermediate, but that is not in your syllabus, right? You don't have that much reactions, right? Now, acha, this is also similar to Kolbe's reaction only. See, Kolbe's electrolysis is different. Kolbe's reaction is different. Kolbe's electrolysis we used to prepare alkane from acid, है ना? Alkane from carboxylic salt of sodium salt of carboxylic acid. But here we are preparing salicylic acid in Kolbe's reaction. In Reimer-Tiemann reaction, we are basically preparing salicylic aldehyde, right? Now, here also what will happen? Firstly, NaOH will abstract the proton here. Electrons will jump here. You will have the formation of phenoxide ion. Then electron will jump here. These electron will jump here. This is the formation same. Again, we know that this is a electrophile because it is having dichlorocarbene is having 6 electrons. This is electron deficient. So, it is going to, basically the arrow is opposite, right? The arrow is opposite. The arrow should not be this. Okay, the arrow should be this. Remember, beta, in organic chemistry, always mechanisms, arrow will be towards more electron density to less electron density, right? So, here more electron density is here, less is here. So, arrow will be like this, right? After this, what will happen? CCl2 will be present here. Now, beta, one by one CCl will eliminate, right? So, basically here what will happen firstly? Here also internal transfer will happen, but this H will not be transferred here. This H will be transferred to this carbon, right? So, here let me just correct it. Let me correct it, guys. This Cl negative will not be over there, but the Cl negative will be present over here. 1, 2, 3, this negative over here, right? Now, what you can see, carbon is having negative because carbon is forming only 3 bonds. Whenever carbon is forming only 3 bonds, it is having one negative there. Now, in the Kolbe's reaction, I'll also show you, okay, so that you can remember the mechanisms as well because these are important. right? In this, hydrogen was internally shifted to this oxygen, right? But in Reimer-Tiemann reaction, this hydrogen is internally shifted to this one, right? Okay. So here what you will see, hydrogen is internally shifted to this carbon. This is CHCl2, and here electrons have shifted here, right? Okay, done. Now what will happen? Now we know that on one carbon, here see, you are adding aqueous KOH. So we know that on adding aqueous KOH, this is the first reaction of haloalkanes, halorine. Add aqueous KOH, Cl will be replaced by OH, right? So similarly, OH is replaced by the OH is replaced here, right? Now here what will happen? On one carbon, a rule of organic chemistry. If you have two OH on one carbon, geminal diol is not at all stable, right? So what will happen? H positive will be eliminated, OH negative will be eliminated, this electrons will jump here, double bond will be formed, right? Same thing will happen here. That means this is CH. Let me just write it in a better way. You can just remember this thing, that here OH is eliminated, H is eliminated, double bond is shifted here. So you have the formation of double bond O, and this is the H. So this is aldehyde is formed. Then you can just acidify it, right? And hence you will have the formation of salicylic aldehyde. Okay? Understood? Chalo. Understood? Acha. Next is Kirchhoff's reaction. Very, very important reaction. Beta, 30 reactions we have done. Okay? Chalo everybody, 30th reaction. Kirchhoff's reaction. So in Kirchhoff's reaction, what we do, again very simple. You just need to have 2-3 concepts here, right? Concept should be clear in this reaction, right? So when we were doing the acidic hydrolysis of alkene, we were using just acid and water. But here we are also using mercuric ions, Hg2 positive ions, right? So here what will happen? Same thing, triple bond, this is CH. You have addition of OH negative and H positive will occur here, right? Because of this reagent. We know that the pi bonds will be shifted to this side. But I am going to take one other, a tough reaction I am going to take here. Let's take, not a tough, actually this is also easy, but this will clear your concepts, right? Okay. Firstly, this reagent means OH negative is the negative part, H positive is the positive part, right? First question that can be asked to you, which you should know, that is pi electrons will be jumped to this side or this side. That tell me guys. If you have actually done GOC, just day 1 is GOC, what I taught you. That is why I tell you that your GOC should be like very strong if you actually want to be good in organic chemistry. It's all about sequence, guys. So let us see, 2 things can happen. If electrons are jumping here, this will be the answer, right? If electrons are jumping here, if the electrons are jumping here on this side, then this will be the answer. We know that CH3 is showing the plus I effect. CH3 very good according to the inductive effect, right? CH3 is showing the inductive effect. So electrons will be transferred here. Positive is like money. Negative is like stress. So positive is like money. You are very poor in money. You don't have money, right? So what will happen here? When you're donating something, right? You are very poor, someone is donating money, you'll feel happy, right? Okay. Now, if you have a lot of stress, negative is like stress, and someone is giving you more stress, you will be unstable. But with money, you will be stable. You want someone to give you money or stress? Money, right? So here, positive means money. Someone is giving you money, that means we are happy. So this will not be the answer. Rather, electrons will jump here. So here what will happen? Answer will be this carbocation will be formed, right? This carbocation will be formed. Here you will have to this negative, we know that there is OH negative and H positive that we need to attach. H positive will be attached here, so it will be CH2. So you can just write here CH2. Here OH negative will be attached, so you can just write OH over here. So you can just write OH over here, and then after this, can you tell me what is this that we have formed? Beta, what is this that we have formed, right? Okay, what is this that we have formed? Satvik, you have told actually a very nice philosophical thing that you have written here. Money is like stress, right? Too much money is like stress, but when you don't have money, that is like, you can't even imagine that stress, right? So yes, as one thing that a very famous quote, you don't have any right to say that money doesn't matter once you earn enough, right? You will see these kind of things only by those people who are very, very rich saying that money is not important, because the ones who don't have, right, who even struggle to eat food, they know the importance of money, hai na? So yes. Now here you have enol, right? This is enol. Enol. This is alcohol and this is ene. So tautomerism, right? Tautomerism will occur here. Tautomerism. Now can you tell me what is tautomerism? Tautomerism is 1, 2, 3. Okay, this I told you in isomerism only. Double bond to this. Okay, what you're going to do? CH3, C double bond, CH2, this is OH. The double bond of 2 and 3 is shifted to 1 and 2, is shifted to 1 and 2. So here what will happen? Pi bond will be eliminated, double bond is shifted over here. Hydrogen of first is shifted to the third position. So here you will have the formation of CH3. So this is the formation of ketone that you will have. This is called Kirchhoff's reaction. Okay, this is called Kirchhoff's reaction. Got it, guys? This is called Kirchhoff's reaction. Right? Very good. Very good. 2 and 3 double bond is shifted here. Hydrogen from first is shifted to the third position. That is tautomerism. Okay? Chalo, very good. Next is Rosenmund reduction. Now we are going to do some direct reactions. Rosenmund. Now, anybody in the comment section, what is the name of this reagent? What is the name of this reagent? In the starting, we have done this reagent. We have done this reagent when we were converting alkyne to cis-alkene. Alkyne to cis-alkene, what was the reagent? Yes, everybody, what was the reagent? Shabash, shabash. Very good, very good. Very good. The reagent was Lindlar's catalyst. Very good. The reagent was Lindlar's catalyst. So here basically we have Lindlar's catalyst, right? Okay. Lindlar's reagent, right? Where the catalyst is PDBSO4, right? Now here COCl is this Cl is directly converted to this thing. Right? If you want to make it more interesting here, you can just directly write here that this is, wait a minute, this is C double bond O and this is H. Okay, students, so this is C double bond O and this is H. Right? Very good. Next question is Stephen's reaction. Anybody in the comment section, what is Stephen's reaction? What is Stephen's reaction? Stephen's reaction, right? So basically in Stephen's reaction, I think I have repeated 2-3 questions. Chalo, no issues. So Stephen's reaction, guys, basically this is when you have SnCl2 in HCl, right? That is Stephen's reaction. When C triple bond N, basically this is C triple bond N, one pi bond will break here and you will have the addition of H and H here. After the hydrolysis, this will be converted to CHO, right? This will be converted to oxygen. So you will have the formation of this. But what we have done, C triple bond N, this is eliminated and you have H and you have H formation here. After hydrolysis, this is converted to CHO. So aldehyde is formed. This is called Stephen's reduction, right? Remember, when you are using SnHCl or you are using FeHCl, that is not Stephen's, That is not Stephens. Okay, that is not Stephens. This is called Stephen, right? Stephen, so SN, yes. But when you're using SN HCl, that is not Stephen. That is a simple reaction, right? This is Stephens. Okay, chalo. It adds a reaction. I'll complete 35 reactions. After that, I'll give you the break. Okay? After that, I'll give you 5 to 10 minutes break. Also, I need some relaxation. Na? Huh. Now, it adds a reaction. It adds a reaction, students. Firstly, this thing is called chromyl chloride. Chromyl chloride. Now, this is basically red in color. Okay? This chromyl chloride is red in color. So when you're using chromyl chloride in presence of CS2, you can just remember this by ET. ET, na, T for toluene. So basically toluene, from this T means toluene, right? So in Itard's reaction, you have toluene where this CH3 is converted to CHO and you have the formation of benzaldehyde in the end, right? Okay. Got it? Chalo. Very nice. Next is Gattermann-Koch reaction. This you can remember by KOCH. So this is like this, CHO. CHO. So basically something related to CHO we are doing. So basically, see, one is Gattermann reaction, other is Gattermann-Koch reaction. Both are different. In Gattermann reaction, we had disonium chloride, right? That was converted into chloro or bromobenzene, right? But here there is no disonium, nothing, right? Gattermann-Koch reaction is just like Friedel-Crafts acylation. I'll tell you the reason. See, in Friedel-Crafts acylation, what we have is, you have this benzene. Now in Friedel-Crafts acylation, what you have is, for example, you have CH3, C double bond O, Cl. You are using anhydrous AlCl3. Isn't this Friedel-Crafts reaction? What we do here, ma'am, we prepare the carbocation here, right? Okay, ma'am. This will react here, and ma'am, what we will have in the end? We will have the formation of this benzene. This is C double bond O. This is CH3. Now, I am saying you need to have H over here. That means you need to have this kind of acyl chloride, right? Okay, right? Now, here, that means you will have this kind of cation. Now, one thing to remember, that formyl chloride is not at all stable. This compound is not stable. That is the reason from benzene, if we want to prepare CHO, we are not preparing that from Friedel-Crafts acylation. That is why we have given it a specific name, that is Gattermann-Koch reaction, where we are preparing this formyl. We are not directly using this formyl chloride because this is not at all stable. So we are preparing this by COHCl, which will eventually prepare formyl chloride, and this is not stable. That is why we can't have it for a long time, right? We have to prepare this while we are doing this particular reaction. We can't just prepare this 1 week before and think that after 1 week we will do the reaction. Not possible. We have to prepare it just when we are doing that particular reaction. Okay, so that is the relation between Friedel-Crafts acylation and Gattermann-Koch reaction, right? So from benzene, directly, definitely you will have this kind of electrophile that will be formed here, and this will attack over here, and hence you will have the formation of this benzyl halide in Gattermann-Koch reaction. Okay, yes, okay, yes, chalo. Now, these two reactions, they are like similar to each other. Clemmensen reduction and Wolff-Kishner reduction. Clemmensen reduction and Wolff-Kishner reduction. So basically, guys, Clemmensen reduction is, you can remember this by, if you understand even a bit of Hindi, right, then you can understand, right, jung ho gayi, right, jung ho gayi, right. So Clemenzin is a son. The son of Clemenzin are fighting with each other. Jung is happening there, right? So jung ho gayi. Basically, this is zinc amalgam. Okay, this is zinc amalgam. If you have any other trick, you can remember by that also, right? So zinc amalgam we are using in acidic condition. Whenever there is some kind of war happening, this is acidic condition, very bad condition it is in, right? So that is why acidic condition, right? So here in Clemenzin and Wolff-Kishner, same reactant, same product, but the conditions are different. This is in acidic conditions. This is in basic condition. This is in basic condition. So here, what will happen? Definitely same thing. This double bond O is converted to H and H. Here also H and H it is converted to. So here it is alkane and alkane are formed over here. Here we have zinc amalgam HCl. Here we have hydrazine, that is NH2NH2, and ethylene glycol with QH, that is giving us basic conditions here. Okay, yes, chalo. I will not forget. I to never forget to send you the notes, right? Okay, yes. Next is tolerance test, right? Now we have 3 tests, right? After these 3 tests, I'm going to give you break, right? So tolerance test, Fehling test, Benedict test. What are the 3 tests, guys? Tolerance, Benedict. Acha, I have also one trick for this one, right? I don't know if you will be able to relate to this or not, but if you relate, then you can remember this, right? So basic condition, Krishan. Basic condition, Krishan. Basic means good condition. Basic is giving us a vibe of goodness. Acid is giving us a vibe of badness, right? Something bad is happening. So good thing. So where we feel positivity in some temple, right? Okay, whatever religion you belong to, you feel happy there, right? Whenever you are in front of your God, like you are peacefully thinking about that, so you feel very peaceful, right? So in basic condition, you can just remember by Krishan, basic condition. Okay, this is how to remember, relate it to your own life, right? So that is, here you can remember this by nahi, right? So you were telling your friend to go to some temple of Krishan ji's temple, then they said nahi, that is why they got reduced. That is why something bad happened there. Okay, you can just remember it like this. Okay, don't judge me for my weird tricks, right? I am though giving whatever I feel. I can tell you, I can make things easy for you, but I know I am not that much creative as compared to Gen Z. Definitely Gen Z is more creative as compared to this millennial, right? So definitely if you have more interesting tricks, write it down in the comment section, because you know, I also learn from you, right? So yesterday I was teaching in the batch and some students gave me such an interesting trick to remember one of the exceptions, right? I was like, okay bro, you are Gen Z, I can't compete with you in level of creativity, right? Okay, chalo. Now, next is weird tricks but superb. Okay, now 3 tests we are going to do. That is tolerance test, Benedict, Fehling test, right? Okay, and iodoform also. 4 tests basically. Let's do that. First test is tolerance test. So this is basically a silver mirror test. In silver mirror test, what will happen? You will have silver nitrate here, silver ammonium nitrate here. What will happen to this thing? RCHO is getting oxidized to, this thing. Here we know that it is having +1 oxidation state. It is having 0 oxidation state. So oxidation state is reducing. So oxidation number is getting low. So that is why here we can say reduction is happening, right? And this is one of my favorite reactions. Like when I was in like your age, 11th and 12th, so I used to get very fascinated by this particular reaction. That was my first experience of lab, and you know, that first experience of lab, when your other reactions I used to find it very boring, like okay, this is happening, that is happening. But here, when on that tube I made that silver mirror, that memory is still in my head, right? It is still in my head, right? So that is why love for this reaction will always be there, right? So this is silver mirror that is formed. Okay, it is silver mirror on the test tube where you're doing the test, that will be formed on the walls of the test tube, it will be formed, right? Okay, now next is, this is a very important thing, beta. This is very important. Usually na, students only know that aldehyde shows these reactions. All the reactions that I'm going to tell you, usually students just know one thing, that aldehyde shows this reaction. But the problem is they don't ask you simple question. They will ask you tough questions. For tough questions, you need to remember these things here, right? That aldehyde, whether it's aliphatic or it's aromatic, beta, this is a very important thing that I'm telling you here. Aldehyde, whether it's aromatic or aliphatic, it will show silver mirror test or tolerance test. It will show, right? Formic acid, that means HCOOH. It will also show this reaction. Can you tell me why? Reason is because it is having HCO. This kind of aldehydic group is present there even in HCOH. That is why it is also going to give you tolerance test, right? Very important, very important. Alpha hydroxy ketone. Ma'am, what do you mean by alpha hydroxy ketone? See, this is ketone on the alpha position. You have OH, right? That means on the alpha position, you have hydroxy. So, alpha hydroxy ketone, like whatever alpha, that means on the ketone, on the alpha position, suppose this thing they are telling, you have this thing. He's saying if you have this kind of structure on the alpha position, you have OH. This is always going to show tolerance test. This students don't know, right? Okay, they only focus on formic acid, aliphatic aldehyde, they show, and aliphatic and aromatic aldehyde. But what about alpha hydroxy? This also shows. Hemiacetal will also show this reaction, right? Hemiacetal means you have a carbon, you have OH, you have OR, you have H over here, and you have this thing. Now, in the next lecture, when we will do important reagents, then also we will do Grignard reagent, hemiacetal, ketal, hemiketal, acetal, then other so many reactions, I don't even remember, like carbocation formation reactions, right? Then you will do DDT formation reactions, all these important reactions, right? Okay, that we will do, right, in the next class. But we are still left with a lot of things, okay? I'm just telling you that hemiacetal, acetal, these reactions are also very important, right? So we will do that in the next class. There is also one question like this, also one reaction which is very important, that also we will do in the next class. That is this kind of reaction. It will make, after this you will have the formation of C double bond NZ R dash, and here you can form oxime, Schiff's base, semicarbazone, 2,4-DNP, right? So many things can be formed here. Okay, just to tell you that we are still left with a lot of important things, right? Okay, chalo. Next is Felling test. In Felling test, what we have is, this is only applicable to aliphatic aldehyde, not for aromatic. You can just write here, not for aromatic aldehydes. So if they ask you how to differentiate, how to distinguish between a ketone and aldehyde, you can say you can use Tollens, Felling, any test you can use. If they ask you how to distinguish between aliphatic aldehyde and aromatic aldehyde, then you can use Felling test, right? What is Felling test? Basically, it is divided into two parts, Felling A, Felling B. Felling A is simple copper sulfate solution. Felling B is alkaline solution of sodium potassium tartrate. So this is basically your tartaric acid, right? Sodium potassium, right? So this is potassium, this is sodium. Tartaric acid is this thing. This is tartaric acid. To one hydrogen, you have replaced it with sodium. Other hydrogen is replaced by potassium, right? So this is called sodium potassium tartrate, right? This is actually a deep blue complex that is formed here, right? In a simple way, we just write down 2 Cu positive, that is representing Felling A and Felling B. Deep blue solution, it is representing. This deep blue solution color is converted to brownish red precipitates in the formation by the formation of Cu2O, and this is only shown by aliphatic aldehydes, right? Ketones, though, it will not show anything, not toluenes, not Benedict, nothing, Felling, nothing it will show, right? Okay. Now, what is Benedict? Ma'am, what is Benedict? Now, Benedict is same as Felling only, right? The only difference is that Felling solution, we can't prepare it in advance. That, okay, on Saturday I have my lab, so I can prepare on Thursday and I'll use it on Saturday. No, you have to prepare it immediately, right? But Felling solution, but Benedict solution, you can prepare it in advance and use it after time. Right? After some time also you can use it. That is why this is a different reaction, a different name is given, that is Benedict test. Otherwise everything is same. Even here you will have deep blue solution, right, which is getting converted to brownish red precipitates of Cu2O, right? Here the difference is, there you were using sodium potassium salt of tartaric acid. Here you are using sodium potassium salt of citric acid. That is the difference. Other things are same. Okay? Got it? Got it, beta? Got it? Yes. Yes, your Santa is here. है ना? Your Santa giving you gifts. Okay, don't spam, Mathan. Don't spam, otherwise I'll have to block you, है ना? So no benefit in doing that. If you're spamming that, I don't even understand what you are saying. So you can say that in English, so that I even understand that what you are telling, what you're saying, right? Okay? Ha. Chalo. Yes. Beta, don't spam, okay? The last warning I'm giving you. Now, haloform test. Haloform test. Haloform test. Acha, haloform test, it is very important test. In haloform test, what we do? You have, first thing is, ma'am, what is the reagent, right? Okay. Reagent is NaOH or X2, right? Or they can also give you NaOX, or they can also give you, yes, okay, NaOH, X2, NaOX. Basically, if you are using, there is a specific test, that is iodoform test, right? Because here this thing is called haloform. This thing is called haloform. And if you have CHI3, that is called iodoform. That is called iodoform. And this is yellow in color. Okay? And this thing is yellow in color. This is going to give you yellow color. Right? Okay? So, specially iodoform test is asked to you. Right? Right? Okay? Now, first thing is, what are the reagents? So, these are the reagents that they will give you. Basically, the reagent is this only. The reagent is NaOH, X2 only. But after reacting, they will form NaOX only. So, they can also give you NaOHI2, NaOHBr2, Cl2, or NaOI. That is the same thing. That means they can confuse you by this. Right? Now, second is that, ma'am, okay, haloform is formed here. But ma'am, which compound will give this reaction? Because we are talking about the test here. So, very important thing to note down here, very important thing, right? That I can't specify that ketones will give this reaction or aldehydes will give this reaction. That is not specified. Or alcohols will give this reaction. There are certain aldehydes, certain ketones that can give this reaction. So, basically, it should have this kind of structure in the compound. If this is aldehyde, it can also give. If this is ketone, it can also give. That means a methyl carbonyl should be present there, right? Only then this is possible. So this kind of compound should be present there, or you should have, if you just hydrolyze it, what you will get? if you just reduce this, what you will get? Break the pi bond, you will add one hydrogen over here, one hydrogen here. So that means the aldehyde or ketones, aldehyde and ketones that have this kind of structure will give this reaction, and alcohols which have this kind of structure will give this compound, okay, will give this reaction. For example, they ask you secondary alcohol. Secondary alcohol is CH3COH here. So you can also write OH over here, right? This is CH2. So this is giving us this kind of structure. That means secondary alcohol is going to give you positive test. And secondary alcohol only where alcohol is present at the second position. So you can't say that all the secondary alcohols will give you this reaction. Only that secondary alcohol which have CH3 directly attached to that carbon where OH is attached, only that thing. So simple way to remember this is CH3, C double bond O, that kind of aldehyde or ketone, or this kind of alcohol can give you iodoform test. Okay? Okay? Understood? Yes, beta? Yes, only these two entities you need to find out to see whether it is going to give you haloform test or not. Right? Okay? Okay. No, I am not. That's why I choose this now. I to never get bored of teaching here. Never get bored of teaching. Reason is, halaki sometimes my throat is like giving up on throat also wants to rest. No, so sometimes I feel like I want to have rest, but I don't feel like boring because when I see the reaction of students, when I see the result of students, when I see that how blessed they feel that okay, ma'am is teaching this thing and I am able to understand. You can never feel bored, right? So it's also what response I get from students. So when the response is good, definitely you have fun. That's why I tell my students that be active in the comment section so that I can't get bored, right? So if you are not active, right, even if someone is teaching for the first time, they will feel really bored, right? But if someone is teaching for the millionth time, even then they will not feel bored because the students are reacting. The students are learning for the first time. That is the best part, that students are learning for the first time. And when they are learning for the first time, the reactions that I get from you, that ma'am, yes, I am able to understand and I feel happy, right? Okay, yes. Now, acha. Guys, now I'll give you the break. After that, we'll do aldol, Cannizzaro and reactions of amines we will do, right? But after the break, okay? Chalo. And I can see all the people, all the students out there. Guys, I also have previous year questions based on naming reactions, right? Now I have collected 60 questions for you, 63 naming reactions for you. We have done 40, right? That means 20 very important naming reaction we are still left with. After that, guys, I have also made a chart for you, right? As you can see here. Let me just show you the chart here. Let me just show you the chart. This kind of chart also I have made for you. So I want to see you all after the break as well. Not like you, okay, ma'am, we will study now, but after the break, so ma'am, we will go. Right? I don't want that thing to happen. Right? Okay? So see you all after the break. How many minutes break? I think 10 minutes or what you want? 15 minutes? I think 10 minutes break is enough. Or 7:40 we can see. Meet you tomorrow again. Arey, why Mohammed? Why tomorrow? Why not today? Today only I want to see you. Okay? Today only I want to see all of you at 7:35 p.m. Right? Okay? 15 minutes? Chalo, theek hai. 7:40. Relax for some time. After that, I'll see you at 7:40. But before that, let me tell you that there is one previous year question, right? That is at discount, right? So this is Focus JEE Test Series plus JEE main previous year question book, where you will get the 1-3. Basically, you will get 44 shift questions here, right? Last 2 years questions you will get here, and 1-3-2-0 question in total of each subject you will get here. right? That is just for 1999. Okay, so that is a very heavy discount that you're getting it on. So avail that thing and start practicing. You still have 1 month, so take advantage of that, right? So that's all I have for you guys. So link is in the description. You can just click on it and go for it, right? Now I'll just resume the class at 7:40 p.m. okay, with a very big smile on your face. This is a girl. This is Diksha ma'am, right? Diksha ma'am teeth are really big here. So let's give Diksha ma'am a very pretty smile, right? A good bindi also. Chalo. Okay. Diksha ma'am will come in some time only. I'll just join you guys after maybe 10 minutes only. Right? Okay. Chalo. Okay. Bye bye. See you all after the break. Hello, hello, hello. Just give me a second. Firstly, tell me, am I visible, guys? Am I audible? Everyone, am I visible? Am I audible? So I am back, guys. Yes, welcome back, welcome back, welcome back. So let us restart this session, right? Ma'am, why resume? Resume. Resume means I have given you a break, na beta? So that's how I was telling resume. Acha. Now, shall we start the session, everybody? Has everyone joined in or not? Yes, Ratan, you got it right. Yes, Ratan. So everyone, are you all back? Yeah, I think Satvik, that is some typing mistake or something, right? I'll make it, I'll ask the team to correct it, okay? Yes, it's last 2 years only. Very good, Satvik, very intelligent, huh? Okay. Now, next we have aldol condensation, okay? Aldol condensation, Cannizzaro, cross-aldol, cross-Cannizzaro, all these are very similar to each other, okay? So, one by one, we are going to do it. First is aldol condensation. So in aldol condensation, they can give you diluted NaOH, diluted KOH, OH in aqueous is also diluted, or they can also give you aqueous Na2CO3 or aqueous K2CO3. All are the same things only, or will do the same work only, right? Okay. Now, I'm just going to tell you that how you're going to solve this kind of question. You have CH3, C double bond O, and this is H. Okay, so I'll firstly tell you that how self-aldol will work. So you have one compound, two molecules will work here, right? First is you need to open the aldehydic part here. Second is you need to open the hydrogen part here. Okay, so you'll open the hydrogen part here, CH2. This is H, this is CHO, right? Okay, so now always remember this carbonyl carbon is going to get connected to the alpha carbon. Okay, this carbonyl carbon is going to get connected to the alpha carbon. What will happen exactly? The answer here will be just these two will be connected to each other. It's just connected here. This will be CH3, CH3, C double bond O, right? Now, one thing to remember that this double bond will be shifted, this will be converted to OH here. Basically, what will happen now? In reality, what will happen? This will shift here. There will be O negative here, and this H positive will shift to this side. And here the electron will shift here, right? So this is the full mechanism, right? But how we will learn this? How we will learn this? Just connect the carbonyl carbon to the alpha carbon here, right? Okay, this is the alpha carbon, this is CHO. This hydrogen is shifted here, so it will become OH here. Rest of the things will remain same. Rest of the things will remain same. Okay, just connect the alpha carbon to the carbonyl carbon. Just connect the alpha carbon to the carbonyl carbon, right? This double bond O is converted to OH here, and this alpha is converted to here, right? So after that, what will happen? After that, what you are going to do? Then water will be eliminated here. For example, this is CH2. Here you have H here. Here you have H. So what will happen? This H positive will be eliminated, OH negative will be eliminated, and this bond will shift here, and hence you will have the formation of CH3, CH double bond, CH, CHO. And the name of this compound is chronoaldehyde. Chronoaldehyde, just like corona, na, you have chronoaldehyde, right? Okay, so when you are using acetaldehyde, or you can say when you are using ethanol, you have the formation of chronoaldehyde, right? Okay, so this thing is called aldol. This is called aldol because here you have one aldehyde and one OH here, and this is called condensation part where water is eliminated. That is what is called aldol condensation, right? That is why it is called aldol condensation, right? Okay, chalo. Now next is the mechanism here. See, mechanism is not important in this case also, but still, okay, you should know how it works, right? Important thing is to generate the final product here, right? But how the mechanism, same thing will happen. Base will abstract the proton from this side, right? Okay, from the alpha carbon here, this is CH2, this is one hydrogen. One proton will be extracted, one bond will shift here, and this will be negative over here. Then what will happen? This will act as a nucleophile, right? Okay, this will act as a nucleophile. So it will jump over. This is partially positive, this is partially negative. This is acting as a nucleophile here. So nucleophile is going to attack on the less electron density situation. So it means this carbon, this double bond will shift here. So answer will be something like this. After that, you are going to eliminate water. Simple guys, you are going to eliminate water and heat it to eliminate the water. That is a condensation part, and you will have answer, right? So that is your mechanism, right? Beta, break to I have already given you. How many breaks you want? Huh? Chalo. Now, cross-aldol condensation. Cross-aldol condensation is this. Now, in cross-aldol condensation, we are going to have mixed products here, okay? So, I'll tell you that how we are going to have mixed products here. So, let's take an example that you have these two things, okay? So, let's take an example. You have these two things. Now, here you will use concentrated base like KOH or NaOH, right? Now, first example is that you have CH3. First is CH3, CHO will react with itself, right? When CH3, CHO will react with itself, that means the same product will be formed. Guys, what we have done now, see, 4 products will be formed when firstly this is reacting with itself, this is reacting with itself. When these two are reacting with each other, then 2 products will be formed. One by one, I'm going to tell you how they are formed. So when CH3COH is reacting with itself, it is going to form CH3, C double bond O, H plus this is CH3CHO, right? This is the same that we have done now. These two will be connected to each other, right? These two will be connected to each other. So here what you will do, answer will be CH3, double bond O is converted to OH here. Here it is H. This is connected to this carbon, so it will be CH2, this is CHO. After elimination of water, you will have CH3, CH double bond, CH, CHO. Right, this is the first product that will be formed here. Second is when CH3, CH2, CHO, CH3, CH2, CHO is reacted with itself. Right, so here you have, beta, in one compound you need to open the carbonyl carbon, in other compound you need to open the alpha carbon. So in our next compound, what I'll do, I'll just show the alpha carbon. So this is CHO, this is the alpha carbon next to it. So I'll be showing that thing only. So this is CH, this is H, and this is CH. It's just a way of writing things. I know to this compound, these are the same compound, okay? Here I have opened the CHO, here I have opened the alpha carbon, okay? Because I know I need to connect these two together, right? So I'll just connect both of them here. What I'll have, CH3, CH2, C. This is converted to OH. This H is as it is here. Then this is connected to this carbon. This H is as it is here. This H is shifted to this side. That is why we have OH over here. Now this CH has one CH3 and it has one CHO. This is aldol. After heating and taking out water, it will be, after heating and taking out water, OH is eliminated from this side, H is eliminated from this side. Okay, H is eliminated from this side, double bond will shift here. You will have CH3, CH2, CH double bond C, CH3, CHO. Okay, so that will be the second product that is formed. Okay, that is the second product. How many of you are able to understand this thing? Everybody in the comment section. Oops. Everybody in the comment section, beta, are you able to understand this thing, how it is formed? Are you able to understand? Yes, everybody, chalo. Yes, functional group plus alpha carbon. Very good, Satvik. Third is when they both are reacting with each other. So in that case, what I'll do? Firstly, I'll make, you have two compounds, CH3, CH2. You have CH3, CH2, CHO. Okay, these two things you have. What I'll do here, in first case, I'll just open the structure of this CHO, right? This is C double bond OH. And in this case, I'll open the structure of the alpha carbon. So here, I'll just write it alpha here. And this is H. So I'll just write the H here, right? So this is alpha and this is carbonyl. These two are connected to each other, right? So what I'm going to do, this is CH3, this is C, this double bond O is converted to which thing, guys? This double bond O is converted to which thing? Everybody in the comment section. This is converted to OH. This H is as it is. This is linked to this alpha, right? This is alpha, na? This is CH. Here H will be shifted here. So we don't need to write this H here. This is CH3. This is CHO. Okay? Okay or not? So you have the formation of this compound. CH3, CH, after the elimination of water, that means OH negative from this side, H positive from this side, you will have the formation of CH3, CH double bond, CCH3, CHO. Right? Okay? Okay. Fourth product, will you form along with me? Will you form the fourth product along with me? Let's see how many of you pick out the pen and notebook and try to form it along with me, right? It's no benefit seeing me and that, okay, ma'am is solving. Yes, ma'am. Okay, good, ma'am. Good, ma'am. Excellent, ma'am. Right? Okay, you have to do this yourself also. So, next is, here I am going to do the opposite thing. Here I am going to open this carbon, right? So, this is C double bond O, H. And here I am going to make this alpha and I am going to open this thing here. Right? So, what will happen? These two will be connected to each other. So, I'll just connect it here. Firstly, I am writing this as the first thing. So, this is CH3, CH2, C. This is converted. Carbonyl carbon is converted to OH. This is H here. This is connected to this alpha. So, this is CH2, right? And this is CHO. Now, here we know that water is eliminated. So, it will be OH eliminated, H eliminated, it will shift here. Answer will be CH3, CH2, CH double bond, CH, CHO. Right? Okay, that will be the fourth product that is formed. Right? Okay. Yes, previous year questions, after we are done with all the reactions, we are left with we have total 60 reactions in total. We are at 41st reaction. Okay. Got it? Chalo. Beta, what I am telling you na, naming reaction, these are your previous year questions only that I am doing. Right? When I am solving, I am doing the previous year questions only. This is not like physical chemistry or physics or math chemistry. Organic and inorganic chemistry is not like physical chemistry, maths or physics. Right? There you have theory is different, practice is different. But here when you are reading the theory, na, you are doing the practice only. Right? Okay. Why can't propanol act as nucleophile? We have, here the propanol is acting as a nucleophile only. Right? Here the propanol, we have alpha. Here we have propanol. This is acting as a nucleophile. Hai na? We have made 4 products in total we have formed. Here propanol is acting as a nucleophile. Here the propanol, the alpha carbon of propanol will be taken out. Here the alpha carbon of ethanol is taken out. Okay, got it? Chalo. Next is Cannizzaro. Cannizzaro is like a disproportionation reaction, right? So you can write it here. It is like a disproportionation reaction. Why? Because one compound is getting converted into, is oxidized and reduced. So this compound with the same number of carbon, it will be converted into alcohol also. That means it is reduced. Plus it is oxidized also to carboxylic acid salt. So it will be HCOONA. That is basically your Cannizzaro reaction. Okay, that is basically your Cannizzaro reaction. Let me just write it here. By mistake, I have used concentrated KOH there. Concentrated KOH was in, it was in Cannizzaro reaction. Okay, concentrated KOH. That is in Cannizzaro reaction. Got it? Yes, everybody, that is in Cannizzaro reaction. Acha. Virat, beta, aldol condensation is only understood by this method. Okay, aldol condensation don't have a specific product. So I can only, this is a shortcut only that I told you, right? So aldol condensation, I can only teach you this way. There is no other way I can teach you aldol condensation, right? So it's not deep, it's actually the way how you will solve the question, okay? So Cannizzaro reaction, disproportionation reaction, one is oxidized, right? This is reduction, and one is reduced. Here it is oxidation, right? Next is, this is the mechanism, right? As you can see the mechanism, same thing will happen. What you need to remember is, one, carboxylic salt is formed, other, alcohol is formed. That's it. Mechanism, they don't ask, right? Cross-Cannizzaro reaction. Cross-Cannizzaro reaction, what will happen? Here, very, very important. Cannizzaro is simple, but cross-Cannizzaro, you need to know one thing here, that less hindered compound will be the carboxylic salt. Now, here you have two compounds. Cannizzaro reaction is happening. Now, important point about Cannizzaro reaction is that in Cannizzaro reaction, no alpha hydrogen you will see. Here you don't have any alpha hydrogen. Here also you don't have any alpha hydrogen. Even here this does not have alpha hydrogen. This also does not have alpha hydrogen. So they will show Cannizzaro reaction. Okay. Now the question is, ma'am, which will form carboxylic salt? So this is less hindered. This is less hindered. So it is going to form the carboxylic salt. So it is going to be HCOONA. This is from the mechanism only. You don't need to see the mechanism. You need to see this thing here, that is less hindered is making the salt. Instead of mechanism, you need to understand this particular point. The answer is in the reason is in the mechanism, right? So HCONA, and this is C6H5CH2OH. That means this kind of alcohol is formed here, right? With the same number of carbon, the more hindered will form the alcohol, the less hindered will form the carboxylic salt. Okay. Next you have esterification reaction. So guys, in esterification reaction, what you have RC. In esterification also, I'll give you one simple thing about the mechanism that is very important. So in esterification reaction, ester is formed here. From carboxylic acid and alcohol, what will happen? Water will be eliminated here, and you will have the answer as ester, right? Now, the question is, ma'am, will hydrogen and OH will be eliminated, or OH from this side and hydrogen will be eliminated, right? Okay, or OH and hydrogen will be eliminated. The answer lies in the mechanism, right? So if you see the mechanism here, if you see the mechanism, what you will see, this is OH, OH is as it is, OH is as it is. OH is getting eliminated, right? So this is what you need to remember, that in this particular case, this OH is only that is getting eliminated. That means the OH from carboxylic acid gets eliminated. That means in the question, you need to remember one thing, what kind of question is formed. OH is eliminated and H is eliminated from this side. That means if they are going to ask you some question like this, you have RC double bond O, OH plus R dash OH. What will be the answer? If this is 16 isotop, this is 16 isotop, this is 18 isotop. Okay, what kind of answer you will get, right? What kind of answer you will get? Now we know that this will break, this will be eliminated, so answer will be RC double bond O, OR dash, but here this is going to be, this OR is, this is going to be 18 and this is going to be 16 isotop, right? Okay, yes, alcohol is going to give you hydrogen and acid is going to give you OH. That is a main important thing about this reaction. Got it? Yes, everyone. Next is Helvohal-Zelensky reaction, HVZ reaction. So this reaction is basically when you have carboxylic acid which has alpha hydrogens there, right? This alpha hydrogen is converted to monohalo compound. Okay, that means monohalo acid is formed, right? Here what you have the presence of X2, whatever halogen you want to replace here with hydrogen, right? Red phosphorus and water, right? This hydrogen will be replaced to this X, that is halogen. So this is called HVZ reaction, right? Okay, Helvohal-Zelensky, that means hydrogen is replaced by halogen, right? Okay, my favorite reaction, really? Okay. Next is Mendius reaction. So Mendius reaction is basically, see, don't get confused in Stefan and Mendius reaction. Stefan is when you have RC triple bond N, this is converted into CHO. That is called Stefan's reaction. When you have SnCl2 and you add HCl there, that is Stefan's reaction. But, right, in this case, when you are doing the hydrogenation in presence of nickel and after that you are also using sodium amalgam in presence of ethanol, in this case, this two pi bonds will break and you will have H2 and H2 in both the cases. When you had Stefan's reaction, what happened? RC double bond N, this is H, this is H, this was converted into oxygen, right? But in this case, in Mendius reduction, what is happening? In presence of the sodium amalgam and ethanol, right? By doing the nickel, in the presence of nickel, you are doing the hydrogenation. These two pi bonds will break and H2 it will have. That means you will have the formation of amines here, right? Okay, chalo. Next is 50th. 50 reactions we have done, guys. 50 reactions is a big deal, okay? It is a big deal, right? Now, let us see Gabriel phthalimide reaction, right? For Gabriel phthalimide, firstly, you need to understand what is phthalimide. It's like a Gabbar. Gabbar was very big, na? It was the villain of Sholay, right? So, Gabbar is very big, okay? So, this is basically your phthalic acid, okay? This is phthalic acid. When ammonia reacts here, what happens? This ammonia, this OH is getting converted to NH2 and NH2. So, this C double bond O, here instead of OH, you will have NH2, instead of OH, you will have NH2. Right, so two amide groups are formed here. After that, by the elimination of NH3, you will have the formation of NH here. This is called phthalimide. This is called phthalimide, right? From this, we will make primary amine here, okay? Right, from this, we will prepare primary amine here. Primary amine will be formed, as you can see. What will happen? I'll also show you the reaction here. Mechanism is also very simple here, not a very big mechanism, right? So this is quite because this is not a proper mechanism, right? Okay, this is just a step. This is not a proper mechanism. Proper mechanism is like a big mechanism. Now, here you have, bacha, here you have KOH. In this, H is replaced by, this is positive, this is negative, with this K positive. Again, this is positive, this is negative. So, R is replaced by this K. So, here, after this, what will happen? When you add NaOH here, this is NaO positive negative. What will happen? This bond will break, this bond will break. This hydrogen will be attached here, another hydrogen will be attached here, one ONA will be attached here, one ONA will be attached here. So answer will be C double bond O ONA, C double bond O ONA, and this is RNH2. That is primary amine is formed here. Got it? Right? Okay. So primary amine is formed. Only primary amine is formed. 2 degree, 3 degree, pure primary amine will be formed. No, any mixture will not be formed here. That's why this is a very, very good reaction. Okay. That's why it's a very, very amazing reaction. Okay. Understood? Chalo. So by adding KOH, RX, aqueous NaOH and acidic hydrolysis, you will have the formation of primary amines here. Now, primary amine is formed. R should never be aromatic in nature. R should never be aromatic in nature. That means this R that you are using here, if you use this kind of thing, wait a minute, if you use this kind of thing, right, then it's not possible. So I am drawing X here only, right? So then the reaction is not possible, right? Because it will have a double bond character here, and that is why it will be difficult to break this CCl bond. Okay? Yes, beta. Very good. Very good. Understood? Understood? Understood what is 49th? 40 to 49th, so beta Mendeus reduction. Simple. This is C triple bond N. This is pi bond. Pi bond. 2 bonds will break. This is H2. And this is H2, you will have the formation of amine here, right? Okay, simple. Okay, chalo. Next we have Hofmann degradation, a very important reaction, very important, right? Hofmann bromomide degradation reaction. Basically, this will be eliminated. You will have the formation of RNH2. One carbon CO bond is taken out here, right? So here what exactly happens? Br2 in the presence of NaOH, right? You will have the formation of RNH2 here. That means this double bond O is taken out from this side, right? Okay, chalo. Now, next is, it is tough. Chalo, let us see the mechanism here, right? Let us see the mechanism here. Mechanism here is important because of this particular step. Everything else is simple, but this step is very unique. This step that I am telling you, this is a very unique step. From here, the question can be asked, okay? In the statement form, they can ask you the question, what will happen here? Yes, 4 mole of NaOH. Yes, you can balance it, 4 mole of NaOH is used here. Very good, Minhaj, very good. Now, you have OH negative. Base will take out the proton, right? So base will take out the proton. This will jump here, right? This will jump here, right? And this double bond will jump here. You will have O negative here, double bond NH here. Now, this is Br and Br. Br, single bond Br. What will happen? Electron will, because of this nitrogen, because of this pi bond here, electron density will shift these 2 electrons. Halaki, these 2 bonds are AA bonds, so they don't have as such electron activity difference. But because of this pi bond here, electron will be shifted to one side, right? And now what will happen? At that point, what will happen? This Br negative will be eliminated, and this Br, which is less electron, which does not have electron, because electron has shifted to one bromine. That is why this is electron deficient. This pi bond will take the advantage, and firstly, the pi bond will give basically lalach. They will be like, hey, I have pi electrons. Then what will happen? This bromine will get very greedy here. That is why electrons will jump here. This pi electrons will take the advantage and will attack on this Br, right? And hence you will have the formation of NBr here, right? And by that time, because this carbon is like crazy. Carbon like, I want to have 4 bonds. Whatever is the reason, carbon is always like, give me for my 4 bonds. I don't care about anyone else, right? Carbon is selfish person, right? So carbon is like, okay, give me back my 4 bonds. Now to this pi bond has gone, now give me my 4 bonds back, right? So that is why 4 bonds here. Now again what will happen, base will again take out the proton, right? Again this will be jumped, then again carbon will be like, okay, now I have another pi bond, so you can take away my electrons. So again this electron got shifted here. Now this step is a very, very important step, right? Okay, carbon is not at all adjusting, right? So this step is a very, till here so everything is simple. What is happening? Base is attacking, taking out proton, electrons are jumping here. Carbon is like, I am crazy, I only want 4 bonds, I can't have 5 bonds, right? Again it is carbon is selfish, right? When pi bonds have taken out with this bromine, then carbon like, I need my 4 bonds back, right? Again this has happened. Now this is a very crazy step, right? This is a very interesting step, okay? You will rarely see these kind of mechanisms, right? That is why this is a very important step. Here what will happen? This negative will be shifted to this oxygen, but here this entire, if you talk about this entire R is shifted to this nitrogen. Okay, I just need to write it here because so that you can understand what is happening here, right? This whole R is shifted to this side. Okay, that means internal shifting is happening. This whole methyl group is shifted to this side. Then to this nitrogen, now you have R. Now this R is connected to this nitrogen, that is why this is R single bond N, then double bond C. Then because this electron is also shifted to this side, they will also have a double bond. That is why again it is double bond O, and bromine is taken out from this side, right? Okay. Okay, yes, okay, chalo. Beta, that I will tell you in the next lecture, okay? Because there are some reactions that still are left in the next class, important reagents. Okay, chalo. Now, oxidation, so I have taken most of the oxidation I will do next only, because ozonolysis, dilute KMnO4, concentrated KMnO4, they all behave in a very different manner. Okay, chalo. Now, this is shifted here. You have R, N, double bond C, double bond O. This is isocyanate is formed in this case. They can also ask you this. Which reagent is formed in between? Isocyanate is formed. After the hydrolysis, what will happen? This will break and you will have the formation of this here double bond O will be attached. This will be CO2 and here 2 hydrogen. Basically, this is water. Water means this thing. Double bond O will be attached here and 2 hydrogens will be attached here. So this will be RNH2 and carbon dioxide is taken out here. Is that clear to everybody? Right? Okay, chalo. Next is carbylamine test. Carbylamine is isocyanate, also it is called isocyanate test, carbylamine test. Right? So in this case you have primary amine, right? This is a test for primary amine, right? Okay, you can write it here. Test for primary amines. This is a test for primary amines, not the secondary amines or tertiary. Primary amines you will have, this is CHCl3COH. This reagent is same as this, so that is why dichloro, I told you this before also, dichlorocarbene is formed here. CCl2, this is formed here, right? And after that you will have the formation of isocyanide. Isocyanide is formed, okay? Isocyanide is formed, that is formed. RNC is formed here, right? Okay, yes. Secondary and tertiary, don't give this reaction. Very good. Now, this is a simple mechanism you have here, right? Okay, if you want to understand, you can. This is the same step that we have done in a Reimer-Tiemann reaction as well, how dichlorocarbene was formed, right? After that, these are the lone pairs. This is electron deficient because carbene has only 6 electrons. So these electrons will attack on this carbon of this carbene and they will join together and you will have this kind of structure. Then what will happen? Cl will be taken out here. Then what will happen? This base will basically attack and take out the proton. This bond will shift here and this bond will shift here, and hence you will have the formation of Rn double bond C Cl. Again, what will happen? Cl will be eliminated. Basically, base will attack over here, right? Double bond will shift here. The Cl will be eliminated, and then you will have RNC, that is isocyanide will be formed. Okay, so it's a simple reaction, simple mechanism you have. Base will take out the proton, this and that will happen. Okay. Acha. Next is Heisenberg test. This is also frequently asked and a very, very simple reagent it is, right? So basically what will happen? This is to distinguish 1 degree, 2 degree and 3 degree, right? 1 degree, 2 degree and 3 degree amines you have to distinguish here. Okay, ma'am. How to distinguish that, ma'am? Okay. So what you have, for example, you have R, taking an example that you have RNH2. This is benzene S double bond O Cl, right? And here I am saying that this is RNH, this is 2 degree. Again, you have the same reagent, right? Okay, this is Cl. Then you have tertiary, right? Then you have tertiary. Now again you have the same reagent. Okay. Okay, this is the reagent. Now, as you can see here, HCl will be eliminated, right? Then what you will have? R, the formation will be RNH S double bond O, this is benzene. Here also HCl is eliminated. Here you will have RN, this is R, this is S double bond O, and this is benzene. Okay? Okay, very good. Again, this will not happen. Here you don't have any hydrogen. So when you don't have any hydrogen, so there will be no reaction in this case. So if you talk about the tertiary, this is primary, this is secondary, and this is tertiary. Tertiary amine will not show any reaction here, but secondary amine will show the reaction, but the answer, this nitrogen does not have any hydrogen here, so it will be alkali insoluble. Right? What about this one? This nitrogen has only one hydrogen, so it will be alkali soluble. Right? Okay, got it. Benzene sulfonyl chloride. Very good, Mohammed. Very good. Benzene sulfonyl chloride is your reagent here in Heisenberg reagent. Okay, that is Heisenberg reaction. This is how you are going to distinguish between 1 degree, 2 degree and 3 degree amines. Next, guys, we have azo dye test. Acha, ma'am. In azo dye test, ma'am, what we do? In azo dye test, what we do? We have disonium chloride. If it reacts with phenol, again HCl will, basically this is a coupling reaction, okay? They are going to give a specific color dye. So when it reacts with phenol, can you tell me what color of dye is formed? Phenol, O for orange. So orange color dye is formed. And what is the, how to draw that? Just draw this benzene. This is N2. This is OH over here. This is orange color dye. What about if you have aniline? Can you tell me if you have aniline, what kind of dye is formed? With aniline, what kind of dye is formed? Here also you take out HCl from here. What kind of dye, guys? I have given you hint here. This is not diazotization, beta. After diazotization, you will have the formation of disonium salt. Then there will be coupling reaction here. COUP, coupling reaction. Okay? Very good. Yellow dye is formed. And what kind of product is formed? This is benzene N2. This is again benzene. This is NH2. Right? The color is yellow color. Okay, this is yellow color dye is formed. Acha. Now this is your previous year question of JEE only. That is why I have picked this also. If you have beta naphthol, then which thing will be formed? Again, from here, HCl will be eliminated. Answer will be something like this. This is benzene. This is N2. This is again not benzene. Yeah, two structures together. Right? Okay. After this, which thing will be formed? Shabash. You can just write it here like this. Now, which thing will be formed? This is OH. This is of which color? Anybody? Okay? Okay. Beta, you don't have to go through the mechanisms here. They are not needed. Okay, you just have to remember the reagent dilute NaOH is used. Definitely it has some use here. That is why proton is abstracted from this side. Right, that's what I am telling you. You don't have to go into the mechanisms of these reactions because they not ask you. Right? Okay, just Ruthu, like you need to get the marks here. Okay, so for marks, what you mechanism I told you, where you need a mechanism that I have showed you. Where you don't need mechanism, you need to do smart work here. Right? Okay, so this is scarlet red dye is formed. Okay, red dye is formed here. Okay, guys, chalo. Now, done. Acha. Next is Hoffman ammonolysis, right? We are just left with 5-6 more reactions. Okay. Hoffman ammonolysis. Hoffman ammonolysis, beta. This is NH3CH3Cl, right? This is basically when you have ammonia, right? And you have RX, right? This CH3 is going to add upon this thing. Right, so on this lone pair, CH3 will be attached from primary. From primary, you have the formation of secondary. Again, after adding RX, again CH3 is attached to this N here. Hydrogen is eliminated. You have the formation of 3 degree. Wait a minute. This is the ammonia. This is 1 degree. This is 2 degree. This is 3 degree. Okay. Here N is attached to only one alkyl group, 1 degree. N is attached to 2 alkyl group, 2 degree. Again, after adding RX, you have the formation of 3 degree. Now you are like, we will again add. We will keep on adding RX. Then again the nitrogen will be like, hey Bhagwan. Okay, so nitrogen you have made quaternary salt. Quaternary salt you have formed here, right? Quaternary salt, 4 R groups on nitrogen, right? That is why nitrogen is having positive and Cl negative. So quaternary salt is formed. That is called Hoffman ammonolysis. Very good, Mohammed. Very good. That is why this is called Hoffman ammonolysis. Now next is this question. They can ask you how many RX you need here. Anyone? How many RX you need here? How many RX you need here to convert it into quaternary salt? This nitrogen is primary. Okay, this is primary. So for primary, you will need 1 RX to convert it into secondary, 1 more RX to convert it into tertiary, 1 more RX to convert it into quaternary. So can I say that how many RX are needed? 3 RX are needed. 3 RX are needed here. Is that clear? 3 RX are needed here. Okay, yes, nice session on the go fire mode on. Very good. Then spam the fire emojis in the comment section, right? Okay, yes, if you're loving this session, then I want to see the likes also, right? Don't be that kind of person who is just here and okay, ma'am is teaching. We will not do anything, ma'am. You do the hard work, ma'am. We will to not even appreciate. Same thing will, backfire you someday. Then you will think that, yes, ma'am used to do a lot of hard work. We never used to appreciate, right? Okay, so what you do, you will also gain the same thing, right? Here, as you can see, guys, how many Rx are needed? This nitrogen is 1, 2, 3. That means this nitrogen is already 3 degree. This nitrogen is also 3 degree. Then how many Rx you need? 1 Rx will convert this particular nitrogen. 2 nitrogen, 2 Rx you need. What will happen? This is, wait a minute. This is N. This is bridgehead nitrogens, both are, right? Here you have added R here. Here you have added R here. This has become positive. This has become positive. So you will need 2 Rx here. 2 Rx, right? Okay. And when your bridgehead carbon nitrogen, that means your bridgehead atom is sp3, then definitely it is stable. So this is also sp3, so it is stable only. Got it? Nahi beta, it is stable only. When on the bridgehead you have sp3 hybridized atom, that is stable. If you have sp2 hybridized atom, that is not stable. Okay, got it? Yes. Bacha, this is sp3 hybridized. 1, 2, 3, 4, right? According to your Brett's rules, which is not possible, this thing is not possible. If you have, for example, this kind of situation, this is carbon, right? This is also carbon. Here, if you are adding 1 CH3, hai na? Okay. Here, if you are adding 1 R here, and now you say, ma'am, this is stable or not, then it will not be stable. If you have on this carbon, I'll just draw the carbon here. If you have 1 positive here, right? If you have this carbon and 1 negative here, then it is possible, but positive is not possible. sp3 hybridized is possible, okay? Chalo. Now, next is Hoffman exhaustive elimination, methylation elimination, you can say. Okay, ready for that? It is related to Hoffman only, just 1 step ahead of Hoffman, okay? Shall we do this also? 56th. 56th. Acha, here what we have is any compound, any compound they have given you, right? First thing is you will cause the Hoffman ammonolysis here. We know that this is 1, 2, this is a 2 degree nitrogen. So you can add 1 CH3 here in 2 degree to convert it into quaternary salt. Beta, first step is to convert it into quaternary salt. To convert it into quaternary salt, I can add 2 CH3I here, right? So, or you can also take it as R, right? I'm just generalizing this by saying CH3 or R, whatever you can add. So this is CH3, that is why CH3 will be replaced here, CH3 will be replaced here, and hence you will have the formation of this, you can say this is 2 degree. How to write 2 degree, right? Now here CH3, that means you have quaternary salt. Hoffman ammonolysis you have done till now. After this, you will do elimination here. How you will do elimination is very important. See, to this nitrogen you will have alpha and beta, right? To this nitrogen you will have alpha, beta, right? Now, both are symmetrical. Now remember that hydrogen is eliminated from beta, right? That is why this double bond will shift here. Here also hydrogen is eliminated from beta, double bond will shift here, but one by one if I show you, one by one we will do. Firstly, from either side hydrogen will be eliminated. This will shift on this position, there will be double bond here. And this nitrogen and alpha carbon bond will break, okay? Nitrogen and alpha carbon bond will break. This hydrogen will be eliminated, one bond will be shifted here. So that is why what you will have, just eliminate this thing and one double bond over here. Beta, just do simple thing, break, I'm just writing one thing here. Break nitrogen and alpha carbon bond, double bond to double bond between beta and alpha carbon. Got it? So what we did here, break this bond, double bond over here. So this is the thing that you have. Now this is nitrogen CH3, CH3, this thing. Nitrogen is having the lone pair. Again you will add methylation. Again you will do the alkylation here. Right? Again you did the alkylation. This is Hoffman exhaustive alkylation elimination. Again you did the alkylation here. Right? Okay. You did the alkylation. This will be CH3 again. This will be positive again. Now again you will have a positive charge on the nitrogen, okay? So again you will have positive charge on the nitrogen. Again the bond, same, break nitrogen carbon alpha bond, attach double bond over here. This is the thing that you will have, and you will have a 3-degree amine. Okay, 3-degree amine will always be formed. They will ask you this thing. In the exam, they will ask you this thing, okay? Hanji beta, tell me. Tell me, bacha, is that clear or not? Is that clear or not? Is that clear or not? One more example. If you have unsymmetrical, right? You have unsymmetrical. Here you have this methyl also. Basically, we know that here firstly, to alkylation will happen. 2 Ri will be introduced. Alkylation will happen. You will have RR and quaternary salt here. This is alpha beta, this is alpha beta, this is alpha beta. Now, the question is, if I talk about this side, ma'am, should I have bond over here or should I have bond over here? Okay? Ma'am, this bond will break. Should I have double bond over here or should I have double bond over here? Understood this or not? Now, understand this point. Hydrogen is removed where degree is less. Hydrogen is removed where degree is less. Degree is less on this position. Here you have this carbon is primary. This carbon is primary. This carbon is 2 degree. So this carbon has less degree. That is why double bond will be formed here. So double bond is formed here and this bond will break. Got it? Hydrogen is eliminated where degree is less. This has less degree. Hydrogen will be eliminated from this side and double bond will be formed here. Right? Okay. So double bond is formed here. After that, again, you are doing the alkylation. Again, you will have positive and this R here. Now this bond will break and here also you will have the double bond. So answer will be this double bond and this double bond, and this is going to be the final answer. Guys, tell me, is that clear or not? Is that clear or not, everybody? Very, very important question. Very, very important. Very, very important for your JEE. Right? Okay, chalo. Try to do this yourself also, because if you just see me, hai na, you will be like, yes, ma'am, I understood. But when you're writing this yourself now, yes, I'll definitely give you the notes. But in some rough notebook, try to write these kind of reaction like aldol condensation, Hoffman exhaustive elimination, because these kind of questions are a little bit tricky. Okay? Chalo. Now next is pina-col-pina-colone rearrangement. Right? Okay. Here also this will be directly asked to you. No tough question will be given to you. So basically this is pina-col. When you have 2 carbons and OH and OH are on the adjacent position, they are pina-col. Right? Pina-col. Now, this particular structure is called pina-col when you have one R, these kind of groups there, right? Now you are doing giving it H positive and heating it. What will happen? H positive and these are lone pair. है ना? Lone pair will be like, Arey, I am electron rich. This is electron deficient. I to want this hydrogen because I am the electron rich, right? So it will attract the H positive towards itself. After that, you will have OH2. Now, oxygen will be like, Arey, I can't handle this positive charge here. Please, I want to get rid of this charge. So, it will take out, it will break this bond and it will be gone. Water will be eliminated from this side. Right? Now, after that, what will happen? After that, you will have a positive here. Now, this is just like rearrangement, pinacol, pinacolone rearrangement. Just like we have carbocation rearrangement, this is pinacol, pinacolone rearrangement, right? Here what will happen? One R group will shift here. Can you tell me the reason here? Reason is, right, now reason is back bonding. I told you in GOC that if you have electron rich and electron deficient people side by side, they will form back bonding with each other. So here you have electron rich oxygen and electron deficient carbocation. They will form back bonding with each other. Because back bonding is getting formed here, that is why this rearrangement is happening. Okay, understood? So because of this back bonding, this rearrangement will occur and this will be formed after the beta. Very simple. This lone pair will be shifted. Basically, it will be like this. This is R, C, O, H, C, R, R, R. This is positive. This is R, this is H. Here what will happen? Here what will happen? This is your lone pair, na? This is the lone pair. This lone pair will be shifted here, right? Then this H positively, this lone pair will shift here, and hence you will have a double bond over here, right? So hence what you can say, this is pinacolone is formed. Basically this lone pair is shifted here, H positive will leave, and you will have the formation of RCO, RCOCr3, right? Pinacolone is formed here. Got it? Chal. Beta, this I think this is repeated only. This we have done before also. Cumene process, I have already done this. Next is Schotten-Baumann reaction. That is also benzoylation reaction. See, the name of this reaction is important for you. That is Schotten-Baumann reaction, right? It's like Baman Irani, if you know. In 3 Idiots, he was that virus. And I remember 3 Idiots virus. 3 Idiots virus, he was writing with 2 hands like this. If I start writing like this, so I'll become a virus from 3 Idiots, right? So it's like Baman Irani. So I to remember this as Baman Irani. Okay, so this is aniline. Here what will happen, right? This hydrogen from here and Cl, this will be eliminated, and hence you will have the formation of NHC double bond O, and this is benzene, right? Okay, and this simple reaction is called, right? Okay, this is called Schotten-Baumann reaction. Now, why this is called benzoylation reaction? The reason behind why this is called benzoylation, because we are adding benzene into this. That is why it is called benzoylation reaction. Okay, got it? Acha. Next is stiffen reduction. This also we have done, right? This also beta we have done this. In SnCl2, you add HCl. There I was showing R group. Here I am showing benzene, right? So this is SnHCl. This is not stiffen, but this is called stiffen. This whole product will be converted to RCHO, right? This also we have done before only, today only. This also we have done Victor-Mayer test, right? Okay, chal. All the naming reactions, beta, they are done. So everyone, we have completed 60 naming reactions. We have completed 60 naming reactions. That's a big thing, right? So are you all happy? Everyone happy about that? We have completed a lot of things now today, right? This is going to be a very, very important lecture. Very, very, I would advise you, right, that you should yourself go through the notes again, right, and try to recall things yourself, right? While you are going through the notes, just hide the answer part and try to recall yourself. For example, this is a reaction. Just hide this part and try to recall what will happen here. This will really, really help you in recalling that what you have studied, okay? And do this today only, right? Okay. Now, beta, these are the charts that I have made for you. I'm not going to repeat it now because today we have already done it. That will be a wastage of time if I do this today only, right? So this is a table that I have made for you. So basically Clemmensen, coupling, diazotization, Wurtz, Fittig, reagent, a reactant, reagent and product that can be formed from here, right? Okay, chalo. Next is Friedel-Crafts, acylation and Getterman-Koch, Helvo-Hunt-Zelensky reaction, Hoffman-Mustard oil reaction. Wait a minute, this reaction I have not taught you. Wait a minute, this reaction I have not taught you. What else? Stefan Getterman, okay, everything else I have taught you. Just let me show you this. Hoffman mustard oil reaction. Hoffman was like, I want to do this also, that also, right? So mustard oil reaction, here you have primary aliphatic amine with the CS2 and HgCl2 and heat, you will form CH3CH2. This is your primary amine. N double bond C double bond S, means N double bond C double bond S. This kind of compound will be formed along with HGS, which is black in color. Okay? Yes? Chalo, I used to do this same thing. Very good, very good, very good. Chalo. Now, next is, let's do the previous year questions, guys. Everyone, let's do some previous year questions. Ready for questions part? Everyone ready for questions part? Let me see how many questions we have. A lot of questions. Chalo, let's speed up the lecture and solve the previous year questions, okay? Ma'am, I'll take Xerox of this reaction, we'll try. Very good, beta, very good. Xerox you need to see, because in Xerox now, you have like this is black PPT na, so I don't know how the Xerox will come out. Acha. Now the first reaction on your screen is major product formed in the following reaction is a mixture of HI. So it is a mixture of. It is a mixture of which thing? Everybody in the comment section. Everybody in the comment section. Right? Shabash, I am waiting for your answers. Let me take little bit break also by the time you're answering. हाँ जी, it's print out. अच्छा जी. Print out में you get the right, मतलब black is also okay with print out or not? अच्छा, चलो let's solve it. Okay. This is a major product formed in the following reaction is major product that is formed here. Acha, this is basically of reagent here. This will be eliminated. Wait a minute. This should not be here because that I'll do in reagents, okay? The questions that are from important reagents that I'm going to delete. Because I only focus on today, the focus is only on those questions which are directly on the naming reactions, not on the reagents. Okay, so that's why I will pick that question in next class, okay? Chalo, because HI is a reagent that I'll tell you in the next class. Phenol treated with chloroform in presence of sodium hydroxide, which further hydrolysis in the presence of. Yes, students, in the presence of. Which thing is phenol in presence of chloroform and KOH or NaOH. The name of this reaction is Reimer-Tiemann reaction, right? Okay, very good. And which thing is formed here? Benzaldehyde is I am saying salicylic aldehyde is formed, but they have given us different names. So salicylic acid, no, this is not 2-hydroxy benzaldehyde. On the second position, this is 1, this is 2, 2-hydroxy benzaldehyde, that is 4th is the correct answer. Next you have, okay, product A, wait a minute, let me see if it is actually naming reaction or not. You have, acha, you can answer this. Huh. This is naming reaction only. Everybody try to answer this. Shabash. Everybody, full naming reaction it is. Everybody in the comment section. Chalo, shabash. Everybody answer this. Everybody. If you talk about the first thing, that is you have alkyl halide in presence of NaOH and C2H5OH. Okay. What you will get? Beta, the first reaction is basically Williamson synthesis only. This is alkyl halide, this is RX. This will form RONA, right? This H will be replaced by Na, right? So here answer will be, which thing will be formed? Ether will be formed. So ether will be formed. A, so they are not asking only. है ना? हाँ. So which thing will be formed? Wait a minute. You have CH3, CH2, CH2, RX, and this is C2H5, Na. Product A you are using. This should be alkene then. Wait a minute, let me see. Alkene is formed, na? Acha, so sorry. This is the ethanol, na? So sorry. This is ethanol. So this is basically a base in alcoholic base. This is alcoholic NaOH. So this is a reagent. Okay, this is not a pure naming reaction. This is a reagent mixed naming reaction. So this is NaOH alcoholic. So what will happen? Br negative will be eliminated. H will be eliminated. You will have the formation of CH3, CH double bond CH2. After this, when you do the acid hydrolysis, you will firstly make the carbocation here. So carbocation will be CH3, CH2. OH negative is attached to less number, so it will be OH and this is CH3. What about diborane? Anti-Markovnikov rule, so it will be CH3, CH2. Negative part to more number, so it will be negative part to negative part more rich to poor, है ना? Negative part to more number only, so this will be OH, this will be H. Anti-Markovnikov, negative part to more number. हाँ, ठीक है? So answer will be 2 and 1. So answer will be C is the correct answer, right? चलो, next is, oh God. Now next is, in Reimer-Tiemann reaction, phenol is converted to salicylic aldehyde through a intermediate. The structure of the intermediate, guys. The structure of the intermediate, they are asking you, what is the structure of the intermediate? We have done the reaction, na? Mechanism we have done. So what was the intermediate that was formed there? In Reimer-Tiemann reaction, you had CHCl2. From there, dichlorocarbene was formed. This dichlorocarbene was attacking here, and because of internal transfer, you had CHCl2. So answer will be A is the correct answer, right? Isn't it? You need to prepare by yourself. I think you are in big need. Okay, next is metachloron treatment with 50% KOH solution yields M-chloro. They are saying M-chlorobenzaldehyde. M-chlorobenzaldehyde means you have benzene here, right? You have aldehyde. Meta means ortho meta. So this is metachloro. So they are asking you metachloro, right? You need to draw it, like you can also draw it like this. Benzaldehyde. Meta means over here. Now you need to tell me metachlorobenzaldehyde 50% KOH solution. Firstly, to tell me what is this reaction? What is this reaction? Anji, what is this reaction? 50% KOH. 50% KOH. Aldol, Canizaro, what kind of reaction they are telling you? Do you have any alpha hydrogen or not? Do you have any alpha hydrogen? Yes, students, do you have any alpha hydrogen? 50% KOH they are saying. M-chlorobenzaldehyde you have, right? That means your alpha hydrogen is not present. So benzaldehyde, it is going to give you Canizaro only, na? So when you talk about Canizaro, one is converted into alcohol, one to aldehyde. So one is converted to alcohol, that is CH2OH. Other thing is converted to benzaldehyde, benzoic, sodium benzoate or whatever, right? Okay. Basically carboxylic salt of sodium. Here we have used K, so it will be K here. So here it will be K. So here it will be CH2 orthometa. So answer will be this, right? So B will be the answer, right? Okay, yes, Cannizzaro reaction, very good. Okay, next we have identify the name of the reaction, guys. What is the name of the reaction? Shabash, everybody. Very simple, very simple, very simple. Very simple, very simple, very, very simple. Hanji, everybody in the comment section. Identify the name of the reaction. Very good. What is the name of the reaction? Waiting for your answers, beta. I am waiting for your answers. Very good, Minhaj. Very good, Minhaj. Others, beta, this is your time. Hai na? I have completed my 3 hours. This is your time to tell me what is the answer. Very good. Answer is Getterman-Koch reaction. That is third is the correct answer. Chalo, very good. Next we have identify the product in the following reaction. Now firstly tell me what is this reaction called. What is this reaction called? You have zinc amalgam. Jang ho gayi. Kahan jang ho gayi? Zinc amalgam in acidic condition. What it is going to give you? What is the name of this reaction? GC ma'am, very good. What is the name of this reaction? That firstly tell me what is the name of this reaction. Name of this reaction, very good. What is the name of this reaction? Very good, Minhaj. Others also, what is the name? The name is Clemenzin. Clemenzin reduction. Okay. So in Clemenzin reduction, what is happening? Only double bond O of aldehyde and ketone are going to reduce. So this will be H and H. This will also be H and H. So ethyl here and ethyl also there. Right? No, not ethyl. This will be carbon C, H and H. Na? So this will be methyl. Methyl, ethyl. Methyl, ethyl. These are two same only. Kya? First and second are same only, or my eyes have gone blind? First and two are same only, na? So sorry. So it should be something else. Yeah, both are correct. Right? This is the correct. So I don't know which of them. Maybe some typing mistake here. Right? Okay. So this both are same structures only. Right? Okay. Now next is they are telling this is the correct. So this should be something else. So I'm just randomly making it ethyl. Okay. So I'm just randomly making it ethyl because one, this is the correct answer. Right? Okay. Chalo. Next question on your screen. The major product X formed in the following reaction is. The major product X formed in the following reaction is. Again, the same question is asked on Getterman-Koch reaction. है ना? Getterman-Koch reaction is again asked to you. What is the product in the Getterman-Koch reaction? Yes, everybody. What is the product in the Getterman-Koch reaction? Shabash. What is the product? What is the product? Very good, very good. Yes, benzaldehyde is formed here, right? Getterman-Koch reaction, beta. This is not Getterman-Koch reaction. Benzaldehyde is formed here. Very good. Next question is, which of the following compound can give positive iodoform test when treated with aqueous solution followed by potassium hypoiodide? Okay. Which of the following will give positive test, beta? Which of the following will give positive test here? I told you for this, which of the following should give the positive, which of the following compound can give positive iodoform test when treated with aqueous solution by potassium hypoiodide? When treated with aqueous KOH. Aqueous solution followed by potassium iodide. This is going, see, this will though definitely not. This is also, basically we need to have this thing, now we need to have this thing, CH3, C double bond O, this thing, or you need to have CH3, COH, H, this thing. It's a very good question, okay? So, here also you don't have CH3, C double bond O, here also you don't have CH3, CHO. Then ma'am, how come this is the answer? Right, I'll tell you that here this will be converted to OH, right? Okay, that's why this will become the answer, right? CH3, CH, and this is OH, right? Okay, that's how this will become the answer. So answer will be first. Okay, chalo. Next is. Next we have identify the product P in the following reaction. Firstly, name this reaction, guys. What is the name of this reaction? What is the name of this reaction? It was one of the student was saying that it's his favorite reaction. Huh? Favorite reaction. Now, so you have to tell what is the name of this reaction. You're saying, no, my favorite reaction, ma'am. Something, something. Yes. Huh. What was the name? Okay, answer is A. Okay, answer. So you have answered it right. Answer is A only. Now tell me what is the name of this reaction. That means alpha hydrogen is getting converted to monochloro compound. Very good. The answer is HVZ reaction, ma'am. Helvohal-Zelinsky reaction. Acha, next question on your screen. You have, okay, nice question. You have benzene with this thing, AlCl3, then zinc amalgam, then concentrated ester. So for you have to tell the answer here. Right? Okay, guys, you have to tell the answer here. Chalo, shabash. Shabash, beta, tell me the answer here. Basically, firstly, though, what we are doing, we are just these two things together in presence of AlCl3, they are going to form, this is benzene, right? This is basically Friedel-Crafts acylation reaction only, right? So I'll just write it here. This is benzene, right? This is benzene, right? This is a kind of Friedel-Crafts acylation reaction only. This is a double bond O, this is O, this is O. From one point, oxygen will be eliminated. This will be O negative, right? Okay. So here what will happen? This will get attached there and you will have the formation of this benzene, right? Okay. This benzene, this is O negative, na? So positive it will be attached here. This will be C double bond O. Then it is 1 carbon here, 1, 2. Then you will have C double bond O. Then you will have O negative. Right? Okay. This is the thing that will be formed here. After the zinc amalgam, we know that this double bond O will be converted to, wait a minute, this will be O double bond, hai na? So this will be converted to, CH2, right? So this will be converted to CH2, right? After that, what you will have? Concentrated H2SO4. Now, after concentrated H2SO4, you will add concentrated H2SO4 there. Then what will happen? This H positive, this O negative will be eliminated from this side and this bond will link here, right? So hence, the answer will be benzene. So answer will be on the second carbon only you have double bond O, so answer will be first. Okay, answer will be first is the correct answer. These two are your name reaction. This is a general method that, okay, concentrated H2SO4 is a dehydrating agent. Okay, it is a dehydrating agent, so it will take out water, right? Okay. So basically, here you had this thing, na? You had benzene here, right? This bond will break. I'm again telling you, this bond will break, right? Here you will have one positive, here you will have negative. That is why benzene will attack over here. So this will be C double bond O, then 1 carbon, 2 carbon, 1 carbon, 2 carbon. Then again you have C double bond O. This is O negative, right? So this will be converted to O positive, OH, right? So this will be OH. I'm just writing it like this, C double bond O, this is OH, right? After that you are converting this into, you are just converting this into zinc amalgam. So this will be converted to CH2. Now after hydrolysis, what will happen? Here you will have H. So it will be eliminated. This OH negative will be eliminated. These two will form a bond. So it will be like this. Okay. It will be like this. It will be like this. Okay, ji? Understood? No, Clemenzin reduction will only reduce the double bond O of ketone or aldehyde. okay, not for carboxylic acid. For here you have the formation of carboxylic acid, na? So for carboxylic acid it will not reduce. Okay, for carboxylic acid, guys, it will not reduce. Okay, got it? Hanji students, got it or not? So I am writing here this product also that was formed, so that after seeing the notes you can understand what happened. This was C double bond O, this was H, this is COOH, right? Here we have added AlCl3, Friedel-Crafts acylation, right? Here there was zinc amalgam, Clemenzin reduction, and then you are also doing dehydration, right? Okay, got it? Hanji. Beta, because that's why Clemenzin reduction is specific for ketone and aldehyde, not for carboxylic acid, okay? Not for carboxylic acid. Before, so many experiments were done on this, na? So it was not able to reduce it, right? Okay. Now, next is, in the given reaction, identify, it's like asking, ma'am, why you have two eyes? Because I have two eyes here, ma'am, why we have one nose? Because we have one nose, right? So experiments were done on this. In experiments, we found out that this is not possible, it is not reducing it, right? Acha. In a given reaction, identify A and B, PDC. Acha. Firstly, guys, you are making here cis. Cis is formed, right? So when cis is formed, this A will be what? This A will be what? This A would be a triple bond here, and this would be CH3, and this would be C2H5, the alkyne, right? So this is CH2, wait a minute, CH2, CH3. It will, numbering will start from this side. 1, 2, 3, 4, 5. It will be 2 alkyne, right? Okay, 2 is present here and here, so this is eliminated. 2 pentyne, that is true. Okay, A, first on third will be the answer. Now they are saying, what is this B? Now when you are using Birch reduction, what will be the answer? Birch reduction, trans product is formed here. Here cis product is formed, so answer will be A is the correct answer. Okay. Yes, beta. Understood. Chalo. Next question on your screen is, okay, this I will do this particular reaction on the reagent part because I have not talked about BH3. We have not talked about Mg, ether, and this we have not talked about. These are basically the important reagents. Okay, these are in the category of important reagents. So this is what I told you, that they ask you question in JEE based on two things, a mixture of two things. One is naming reaction, like this is a naming reaction of hydroboration oxidation, right? This is hydroboration oxidation, and this particular HB, HBr, Mg, ether, then H, this is your important reagent. So we will, I'll give you the answer. We will solve this question tomorrow, right? But this thing I'll tell you that in first two cases, what is happening? This is pH, right? pH means phenyl, right? Okay, pH means phenyl. This is CH, because tomorrow we will do the third and fourth part. Then in the end, what will be the product? But what about 1 and 2 reagent? What will happen? This is CH, this is double bond CH2. This is following anti-Markovnikov rule. Anti-Markovnikov rule. So here, negative charge, negative, that means OH is attached to more number of hydrogens. So that will be here and H will be here. Basically, this thing is formed. Okay? Understood? Ha. Anti-Markovnikov rule is applied here. Okay? Yes. Chalo. Done, beta? Acha. Now, these two things we will do in the next lecture. Next lecture. These are important. This is day 4. Okay? This is a lecture of day 4. In day 4, though, you will see really interesting question. Because most of the questions are mixture of these two things, right? Okay, this is ozonylysis. This also we will do in the next class only, because ozonylysis also I'll take up in the next class. Okay, chalo. Hai na? Because ozonylysis also is a reagent that I'll take up in the next class. So tomorrow in the next lecture, that is Tuesday, we are going to cover very important things. Grignard reagent, ozonolysis, KMNO4, K2Cr2O7, dilute, concentrated. These are just limited that I am telling. Around there are 30 to 40 reagents that I am going to discuss about. Right after that, we will do questions based on naming reactions plus important reagents mixed. As you have seen that I have told you this reaction, most of the questions are like that only. They will give you 1 to 2 naming reactions in between. They will give you 2 to 3 important reagents. And those reagents only, those naming reactions only, they are making new questions from that. Right? So, next lecture is going to be very important, but important thing is, if you directly jump to, if you have not seen day number 1, if you have not seen day number 3, because isomerism is not related. Isomerism is not related to day 3, 4, 5. Okay, it is not related. But day 1, day 3, and day 4 and day 5 are interrelated. So tomorrow's lecture, Tuesday's lecture, you will be able to understand only if you have gone through the naming reactions, because important reagents are not related to naming reactions, but the questions that we are going to solve will be directly related to naming plus important reagents. Okay, got it? Yes. Chalo. Haan. Very good, Aryan. Aryan, excellent. Chalo. Okay then, beta. Bye bye. Take care. Okay. Bye bye. Bye bye. Rest of this lecture immediately, ma'am. I'll watch the rest of the lecture immediately. Very good, beta. Very good. Ma'am, question solving session, ma'am. Beta, question solving session I'll solve in the day 5. The day 5th is going to be a really awesome session, right? Where naming reaction, important reagents, I'll give you a lot of sequence, right? A to B, B to C, C to D, D to E, E to F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, Z, right? So you will have, I'll give you flow charts from where mixture of naming reaction and important reagents we will solve, right? But the base I am forming right now is naming reaction, then important reagents. Then we will see what kind they ask you in the exam. If you follow these 3 days, now day 3, day 4, day 5, you watch these 3 days, I can guarantee that not even a single question from organic chemistry, especially on organic chemistry reaction, you will miss. I can guarantee you that. Okay? Yes. Chalo. Okay, then bye bye, beta. Take care. See you all in the next class. And don't forget to like this session, share this among your friends. And I'm literally waiting for your comments, right? Okay. So as you know that I have just joined this channel maybe 1 month back, right? It's not like a really long time, and I'm really happy. The love that you guys are giving me, the acceptance that you have given me. Firstly, so thank you so much for that. That means the world to me, because I was really skeptical about this. That okay, you know, when students are like, okay, they're like getting taught from one teacher, it's very difficult to accept the other teacher, right? I can totally understand that. But the way you have given me so much love, right, that is seriously, thank you so much for that, right? That makes me more motivated. But I want to have a personal connect with you guys also. So I want to see your comments in the comment section, that what you want me what kind of lecture you want me to come up with in the next series after completing organic reactions. Okay, and how you're liking this series. Okay, yes. Chalo. Okay, bye bye. And before going, guys, as I told you, this is your Diksha ma'am with that red bindi. Achha. But as I told you, that practice is very important right now. Okay, so after going through this, you also need to practice the previous year questions yourself. Now there are a lot of previous year questions even in last 2 years. So that's why for last 2 years we have all the 44 shift questions solved, right? No, there is no incorrect thing you will find here, right? That is why here we have made this for 1999. It was earlier 5998, but now because your exam are really near, we know that how important for it is you to do the previous year questions right now. So don't miss this opportunity and grab this offer. It will be delivered to your house, and as many questions as you can solve in next 1 month. Do that, make day and night equal, and study as much as possible, right? Okay, chalo. Okay then, beta. Bye bye. Take care. See you in the next class. Bye bye. Waiting for you.